Start? Yeah. Hello, check, check. Good evening to one and all. Hello and welcome to everybody. Wish to start the day bright with a Sanskrit verse from the shloka. Guru Brahma, Guru Vishnu, Guru Devo Maheshwaraha, Guru Sakshat Parabrahma, Tasmai Shri Gurave Namaha. Guru is the dispeller of darkness, who is the creator of self-knowledge, preserver deity who destroys the ignorance. Great salutation to our Guru, Professor CEG.Justo, who taught and demonstrated. Coming together is beginning, keeping together is progress, and working together is success. Respected dignitaries, respected teachers, fellow alumni, students and friends. On behalf of the Association of Bangalore University Highway Engineering Alumni, it's my privilege to welcome you all to Professor CEG.Justo 6th Endowment Lecture 2025. In the earlier series of the Endowment Lecture, we had experts from India and as well abroad giving insight on variant relevant topics, including Model Road Design Guidelines for Urban Streets for Better Quality of Living in the year 2020. That was the first endowment lecture. Ground Penetrating Radar Technology for Bituminous Pavement Evaluation in the year 2021. Urban Road Asset Management in the year 2022. Technical lecture on Recycling Techniques for Sustainable Urban Road Infrastructure, followed by a panel discussion on Sustainable Urban Transport for Bangalore, Challenges and Solution in the year 2023. ATMS and IoT-based smart city solutions for congested cities in the year 2024. And this year, we have the agenda as part of the 6th endowment lecture, the keynote lecture on premature failure in flexible payment with emphasis on top-down tracking by Professor Sridhar Raju, Department of Civil Engineering, Pitchpilani, Hyderabad campus, followed by a technical talk on designing sustainable roads by Shri Lokesh TR, Director Infra Support Engineering, Consultant Private Limited. Then further, this would be followed by a panel discussion on Indian urban roads, mobility and sustainability with eminent professionals on the panel across from BBMP, from Police Department, as well as industries. I'm sure by end of all the sessions, we are confident that these knowledge sharing of experts during the various sessions will have key takeaways in the benefit of majority of the audience here. With this brief intro, let me introduce and as well as invite the dignitaries and as well as the President and Secretary of the Association onto the dais. Now I request Dr. A. Veeraraghavan, President ABUHI, to occupy the dais. I'm sure everybody know Dr. Veeraraghavan, sir. He basically needs no introduction. But however, in a formal way, Dr. A. Veeraraghavan, superannuated as Professor of Civil Engineering from IIT Madras in the year 2021. He has over 44 years of experience in teaching, research, and industrial consultancy. Professor Veeraraghavan received several awards from the IRC, ISTE, CIDC, and IIT Madras. During the year 2021 and 24, Professor Veeraraghavan was actively involved as member of various committees, including Highway Specifications and Standards Committee, Flexible Payment and Airfield and Runway Committee, Composite Payment Committee, Rigid Payment Committee, and Road Maintenance and Asset Management Committee of IRC. Also, he was a member of the expert working group constituted by the IRC for the 6th revision of the MRTH specifications for roads and bridges. He is also a member of Technical Committee of Karnataka Road Development Corporation. He is also chairman of the committee to introduce new materials and technology in rural roads by NRIDA. Professor Veeraraghavan, sir, is a technical advisor to Rasta. Now, he also will play a key role in the new committees which are yet to be constituted by the IRC for the year 2025 to 27. We welcome you, sir. And I request Dr. Chetana and Praveen to do the honors as a token of love and affection. So amongst the August gathering, we also have the honor, and as is a privilege, we have two guests for the today's event. Shri Shankar F. Patel, Shankar Gowda F. Patel, KES, Chief Project Officer, KSHIP. Welcome you, sir. And also Dr. B.S. Prahalad, Engineering Chief, BBA. I request Shankar Gowda Patel, sir, to occupy the seat. Dr. Shankar Gowda F. Patil has done his MSc in Civil Engineering from VTU, and also he has done his BE in Civil Engineering, and he holds the credit of having the first rank, and then he graduated from BVB, College of Engineering and Technology, Hubli. Currently, he is the Chief Project Officer, Karnataka State Highway Improvement Projects, KSHIP, Public Works Department, Government of Karnataka. He has a vast experience starting his career as Assistant Executive Engineer after he joined through the Public Service Commission in the year 1995. Since 6 years, he has been working as a Chief Engineer. And as a Chief Project Officer, KSHIP, he has handled externally aided projects costing close to 5,334 crores. That's a massive work. So amongst his special achievement, he has been instrumental and has played a major role in finalizing the site as well as the construction of Suvarna Sauda building, which is around 65,000 square meters in Belgaum. And also, notably, he is instrumental in finalizing the execution of Greenfield Airport in Vijaypura in North Karnataka. During the last year, that is November 2024, during the annual IRC session held at Raipur, Chhattisgarh, he was also selected as Vice President, Indian Road Congress. Also, Government of India has nominated him as one of the technical member during the year 2024 to 27 to the World Road Congress, PIARC, Paris in France. And then he has a vast exposure traveling abroad as a technical tour where he has brought in a lot of technologies. And then in the year 2005, he had a visit to Melbourne, Australia with basically a visit that was envisaged to identify the best practices in the road construction, and that was sponsored by Government of India. And that apart, he also visited Seoul, South Korea in the year 2019 for the official executive training. And also he has visited the other states, USA, UK, Switzerland, Singapore, Malaysia, and UN. Also, he has attended close to about 10 international and national conferences, and also the technical papers have been published in the National Technical Journal. So we welcome you, sir. I request Dr. Chetna and then Lokesh to do the small honors to him. Thank you. Now we have another eminent person in the gathering, Dr. B.S. Prahalad, sir. So we request you to please kindly occupy the seat. Dr. B.S. Prahalad, he started his career as a junior engineer in BBMP from 1993, and later he joined AMA course, and he has worked in various capacities from assistant engineer to assistant executive engineer to superintendent engineer. And currently, he is the engineering chief of BBMP and also is the board member of BWSSB. Then, he is also a technical member of the multimodal integration of Bengaluru City and technical member of Karnataka Non-Motorized Transport Agency. So, Dr. B.S. Prahalad is an ardent learner and enthusiastic and has enrolled himself to also achieve a doctorate in civil engineering. He has been awarded the doctorate in the asphalt mixes. Further, when he was working as a chief engineer, he has been instrumental in building connectivity roads to new international airport on Yelahanka on the Bangalore side. He introduced on the road smart parking system in 85 roads of Bangalore, which is citizen-friendly and no manual intervention system. While he was a chief engineer, technical vigilance cell from 2017 to 2018, so he has worked extensively for the elimination of the sewage water mixing up into the stormwater drains and then thereby to the lakes. Also, Dr. B.S. Prahad was selected by the state government to head the BBMP engineering department in the year 2022. He has been responsible for the overall engineering wing of the BBMP and directly heads the road infrastructure and street lighting electrical wing of BBMP K100 Citizen Waterway project. That apart, he's also brought a transparent system of identifying the locations of potholes and repairs of potholes through GPS coordinates, and the same has been released in the public domain through a mobile app called Fix My Street. And then he has also taken various initiatives, especially with respect to the concrete road technology, like precast road construction technology for the rapid roads. He has also initiated to adopt the AI technique for road inventory of Bangalore city roads. I'm sure with his vast experience, all the audience are going to have a key takeaways from this technical session with their expertise and knowledge sharing. We welcome you, sir. I request Dr. Chetna and Praveen to do the honors to Dr. B.S. Prahad, sir. Now it's my privilege to invite Sri Ratnakar Reddy, the Secretary of the ABUHI, onto the stage. Mr. Ratnakar Reddy currently is the Managing Director of Infra Support Engineering Consultants Private Limited. He was born and brought up in the Kiruvara village in Srinivaspura Taluk, and then he has completed his school at the village and as well as the neighboring village of Srinivaspura town. So he has studied in Kannada medium school, and then today he offers, being an entrepreneur, he offers job to many of the engineers. That is a big credit there. He has graduated from civil engineering from SIT, Tumkur, and also masters from highway engineering, UEC, from Bangalore University with a gold medal. So Mr. Reddy has over close to 24 years of experience in the design and project management of several roads, highways, and urban infrastructure and transportation projects. He has authored and also co-authored over 13 technical papers which are published and presented in the national, international proceedings and journals like IRC, TRB, etc. He is a life member of Indian Road Congress, life member of Indian Concrete Institute, and also past elected council member of the Indian Road Congress. He is the founder and managing director of Infra Support, a company which was started in the year 2007 at Bangalore and has close to about 250 engineers working on various infrastructure projects. So Infra Support basically provides consultancy on the design, the construction supervisions for the traffic and transportation, as well as the building structures, railways, and urban infrastructures. So the company is listed under 10 most valuable engineering and infrastructure companies in the Insight Success Magazine November edition 2016. So in recognition of his service, he has been recipient of Professor CEG.Justo Medal for outstanding performance during his master's, and Century International Quality Era Award, which was at the Geneva, Switzerland 2015. He is also a recipient of ICI Young Engineer of Karnataka for the year 2015 for outstanding work in civil engineering, and also an Young Entrepreneur Award from Indian Council of Commerce and Industry, Delhi, 2016. I'm sure with his vast expertise and then knowledge sharing during, everybody would also be benefit on that. I welcome you, Sri Ratnakar Reddy. I request Dr. Chetna and Praveen to do the honors as a token of love from the association. Thank you so much, Dr. Chetna and Lokesh, as well as Praveen. Now let's start the event by invoking the blessings of Almighty. I warmly invite Ms. Sukriti for the invocation song.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಶರಣು ಸಿದ್ಧಿವಿನಾಯಕ ಶರಣು ವಿದ್ಯಾಪ್ರದಾಯಕ ಶರಣು ಸಿದ್ಧಿವಿನಾಯಕ ಶರಣು ವಿದ್ಯಾಪ್ರದಾಯಕ ಶರಣು ಪಾರ್ವತಿ ತನಯ ಮೂರುತಿ ಶರಣು ಪಾರ್ವತಿ ತನಯ ಮೂರುತಿ ಶರಣು ಮೂಷಿಕ ವಾಹನ ಶರಣು ಸಿದ್ಧಿವಿನಾಯಕ ಶರಣು ವಿದ್ಯಾಪ್ರದಾಯಕ ನಿತಿಲ ನೇತ್ರನೆ ದೇವಿ ಸುತನೆ ನಾಗಭೂಷಣ ಪ್ರಿಯನೇ ನಿತಿಲ ನೇತ್ರನೆ ದೇವಿ ಸುತನೆ ನಾಗಭೂಷಣ ಪ್ರಿಯನೇ ತಟಿತಟಾಂಕಿತ ಕೋಮಲಾಂಗನೆ ತಟಿತಟಾಂಕಿತ ಕೋಮಲಾಂಗನೆ ಕರ್ಣಕುಂಡಲಧಾರಣೆ ಶರಣು ಸಿದ್ಧಿವಿನಾಯಕ ಶರಣು ವಿದ್ಯಾಪ್ರದಾಯಕ ಶರಣು ಸಿದ್ಧಿವಿನಾಯಕ ಶರಣು ವಿದ್ಯಾಪ್ರದಾಯಕ ಭಟ್ಟಮುತ್ತಿನ ಪದಕಹಾರನೆ ಬಾಹುಹಸ್ತ ಚತುಷ್ಟನೆ ಭಟ್ಟಮುತ್ತಿನ ಪದಕಹಾರನೆ ಬಾಹುಹಸ್ತ ಚತುಷ್ಟನೆ ಇಟ್ಟ ತೊಡುಗೆಯ ಹೇಮ ಕಂಕಣ ಇಟ್ಟ ತೊಡುಗೆಯ ಹೇಮ ಕಂಕಣ ಪಾಶ ಅಂಕುಶಧಾರನೆ ಶರಣು ಸಿದ್ಧಿವಿನಾಯಕ ಶರಣು ವಿದ್ಯಾಪ್ರದಾಯಕ ಕುಕ್ಷಿಮಹಲಂಬೋದರನೆ ಇಕ್ಷುಚಾಪನ ಗೆಲಿದನೆ ಕುಕ್ಷಿಮಹಲಂಬೋದರನೆ ಇಕ್ಷುಚಾಪನ ಗೆಲಿದನೆ ಪಕ್ಷಿವಾಹನ ಶ್ರೀ ಪುರಂದರ ಪಕ್ಷಿವಾಹನ ಶ್ರೀ ಪುರಂದರ ವಿಠಲನ ನಿಜದಾಸನೆ ವಿಠಲನ ನಿಜದಾಸನೆ ಶರಣು ಸಿದ್ಧಿವಿನಾಯಕ ಶರಣು ವಿದ್ಯಾಪ್ರದಾಯಕ ಶರಣು ಸಿದ್ಧಿವಿನಾಯಕ ಶರಣು ವಿದ್ಯಾಪ್ರದಾಯಕ ಶರಣು ಪಾರ್ವತಿ ತನಯ ಮೂರುತಿ ಶರಣು ಮೂಷಿಕ ವಾಹನ ಶರಣು ಸಿದ್ಧಿವಿನಾಯಕ ಶರಣು ವಿದ್ಯಾಪ್ರದಾಯಕ. ಧನ್ಯವಾದಗಳು.
Thank you, Sukriti. So that was really wonderful. And let's put up a big round of applause for creating a positive, vibrant start to commence the technical event. Thank you once again. Now, I request the dignitaries on the dais to light up the lamp to start the event, and also as a tribute to the professor.
शुभं कुरु त्वं कल्याणम् आरोग्यं
Thank you, sir. Now I request Sri Ratnakar Reddy KB, the Secretary of the ABUHI, to give a welcome address.
Thank you, Uday, for the wonderful beginning and the welcome. Respected dignitaries on the dais, distinguished members, students, I'm not going to take more time here. This is the 6th Endowment lecture of Professor CEG.Justo. A long time back, about 10 years back, we thought we'll start this association with the only objective of remembering Professor Justo sir, conducting seminars and programs on his birthday, and spreading the message of his teachings, and in whichever way helping the fellow professionals. That's the only objective of this organization. Like Uday said in the beginning, coming together is the beginning, staying together is the progress. What we are doing in the association is, keeping everyone together. In the present days, while everyone is busy in their own life, in their profession, and with the advent of online, now we can learn whatever we want by searching, in the internet. But we need to create an occasion to, come together, meet together, and greet together. The whole objective of, doing this, we could have done an online event, and everyone could have, sat and listened to the talk. But we thought we'll do an hybrid so that, whoever wants to come, and in fact, we want people to come, alumni to come and see, meet and greet. That's the whole objective. And thank you all for, taking your time, coming here. It means a lot for us, so that it motivates us to keep doing such events all the time. Thank you all.
Thank you, Ratnakar. Now I request Dr. A. Veeraraghavan, the President of the ABUHI, to give a brief on the life of Professor CEG.Justo.
Thank you, Uday. Mr. Patel, Chief Executive Officer from the KSHIP, Dr. Prahalad, alumnus of Rasta, and the Engineering Chief of Bangalore Mahanagara Palike, Mr. Sanjay Justo, representing the Justos family here, Dr. R. Sridhar, the speaker for today's endowment lecture from BITS Pilani, Hyderabad, Mr. Jayaprasad, a good friend of Professor Justo for decades and decades, and my good friend as well. Dr. Ramchandra, again, an alumnus of UVCE and a good friend of me, and now continuing in Rasta. Mr. Nagaraj, President of this Karnataka State Center. Mr. Ratnakar Reddy, Mr. Lokesh, and others, all students and students who are assembled here for this endowment lecture. So I, as President of this association, I extend a very warm welcome to one and all of you. It's my duty to inform to you about Professor Justo. Few may know, many may not know. The students may not know about Professor Justo. So it's my duty to introduce Professor Justo on this event. Professor Justo is 90 years today. Professor Justo was born on the 11th March 1935 at Nagarkoil, the earlier part of the Travancore state. He graduated with a BSc Engineering from the College of Engineering to Thiruvananthapuram in 1958. He obtained his ME Highway Engineering as well as PhD degrees from the University of Roorkee in the year 1960 and 1972 respectively. He is a Fellow of the Institute of Engineers, IGS, and a member of the Indian Rose Congress, Indian Society for Technical Education. He started his career as a faculty member in the year 1959 at TKM College of Engineering, Kollam, and he worked there till 1963. He taught at the University of Roorkee, now currently IIT Roorkee, during the period 1963 to 1973, During this period, he wrote the book and published the book, 2 books, one on highway engineering, second is highway material testing, which are jointly authored with Professor Khanna. I am fortunate to be the 3rd co-author for the book on highway engineering and highway material testing. And the 11th edition of the book is under print. So soon we will get the updated version of the 11th edition of the highway engineering book. It has survived several other books for the last 50 years and more. He relinquished the services officially in the year 1995 on super innovation, but continued to extend his guidance as emeritus professor at Bangalore University till 2000. After joining Bangalore University in the year 1973-74, he took the lead and started the master's degree program in highway engineering at the university and nourished it to be a center of excellence in transport engineering in the country. The highway engineering department division of the Bangalore University, under his leadership and guidance, has produced hundreds of highly competent highway engineers and scientists who are now occupying the key positions in the industry in the country and abroad. Prof. Justo strongly believed in translating theory to practice. He established a very strong relationship and bondage with the user organizations like Karnataka Public Works Department, Traffic Police, Ministry of Road Transport Highways, and many consultancy companies and construction industries. By this process, what he did was that he exposed all his students to the field problems and trained them to be practical engineers and effective in the field of highway engineering in the whole country. In addition to the academic activities, Professor Justo contributed to the administration and policy making at the Bangalore University in the various capacities as head of the department, chairman board of studies, dean engineering, principal UVCE, and an interim vice chancellor of Bangalore University as well. He visited US under the US Indo-US Collaborative Exchange Program, visited Michigan State University, University of California in the year 1989. Apart from teaching and guiding students and research scholars at the university, Prof. Justo played an effective role in shaping the policies, standards, practice in the field of highway engineering in the country through his participation in various technical research and advisory committees as chairman, convener, member, advisor, constituted by Ministry of Road Transport Highways, Indian Roads Congress, Central Road Research Institute, Karnataka Road Development Corporation, Bangalore Mahanagara Palike, BDA, BMTC, and many more organizations. Prof. Justo was bestowed with the Lifetime Achievement Award for his outstanding contribution in the field of highway engineering by the Indian Roads Congress at the 78th annual session of IRC, held at Bangalore in the year 2017. Due to his health, he could not receive the award in person. On his behalf, I received his Lifetime Achievement Award during the annual session of the IRC. Later, Professor Justo was bestowed with the Rajyosa Award thanks to initiatives of Mr. Jayaprasad. He was bestowed with the Lifetime Rajyosa Award in the year 2019 by the government of Karnataka in recognition of his dedicated services and contribution to the public through his profession. Professor Justo left for his heavenly abode on the 22nd June 2019. As rightly mentioned by Ratnakar Reddy, he taught us coming together is beginning, keeping together is progress, and working together is success. The greatest sign of success for a teacher is to be able to say, the children are now working as if I did not exist. So I think Prof. Justo has taught us a very good lessons, and this is today's meeting is an example that we are working together, maybe based on his principle of dissemination of knowledge. We have created many WhatsApp groups. Day in, day out, we share the knowledge, disseminate the information. I think both Mr. Patil and Dr. Prahlad are members of the Road and Transport Engineering group, WhatsApp group. Many students and teachers are group members of the Transport Engineering Faculty Group of India. We have a higher information group. I think more than thousands of engineers are being benefited through this knowledge sharing process. I'm happy and proud to say that I was a Justo's PhD student. I joined here for his PhD in the year 1981 and continued the relation with Professor Justo till his death in 2019. I think today is the 6th endowment lecture that we have planned. Every year we used to plan on the 11th of March. Today is the 6th endowment lecture. We always identify a distinguished alumnus to talk deliver the lecture. Today, we have invited Dr. Sridhar from BITS Pilani, Hyderabad. So he has kindly consented to be a part of this group and share his knowledge on the premature failures. I am sure that his talk on premature failure based on his extensive experience, as well as the talk by Mr. Lokesh on the sustainable payment for urban routes, and thirdly, followed by a panel discussion on sustainable urban mobility and transport, a case study of Bangalore. We have eminent speakers. I'm sure that end of the day, you all go home filled with a lot of knowledge, food for thought. I'm sure that this knowledge sharing process will continue in the years to come. Those of you who are not members of the WhatsApp group, kindly become a member and share your experiences so that we also learn the process, and whatever little we know, we can also share with you. So in the whole process, I always tell my PhD students, the outcome of the research should be to improve the quality of the life of the people. If by this knowledge dissemination process, if we can improve the quality of construction of the roads in the country, and if all the entire community is benefited by this, then we have served the purpose. I'm sure that we will take this forward in the years to come as well. I take this opportunity to thank both Mr. Patil and Mr. Prahlad to having come here to share his knowledge as a guest of honor today, and later share that knowledge to the panel discussion as well. So I welcome you all on behalf of the association, as the president of the association, and we look forward for the interactive panel discussion at the end of this day's proceedings. Thank you very much.
Thank you to Professor A.V. It was really a wonderful insight about Professor CEG.Justo, and also the way how a teacher experts and then what are the students here from the highway engineering alumni here. So thank you once again, sir. As Dr. APJ Abdul Kalam said, the role of the teacher is like a proverbial ladder. It is used by everyone to climb up in the life, but the ladder, that is the teacher itself, always stays in its place. We thank Professor A. Veeraraghavan sir for sharing us the precious lessons from Professor CEG.Justo sir's life. We are sure that at least we would put our best efforts in imbibing these principles in our day-to-day life and also on the professional front. As we express our gratitude, we must never forget that the highest appreciation is not to utter words, but to live by them. Thank you, sir, once again. Now, I request our guest of honor, Sri Shankar Gowda F. Patel, sir, CPO K-Ship, to address the gathering.
Good evening to all. Dignitaries on the dais, Professor Veeraraghavan sir, Prahlad sir, and Ratnakar Reddy, Secretary, Association of Bangalore University Highway Engineering Alumni, dignitaries of the dais, our respected engineer sir Jay Prasad sir, Nagaraj, and other engineering fraternity, students, ladies and gentlemen. I'm really happy to be here with you all today. When I was a student of M. Nagaraj in BVB, we used to go through books of CEG.Justo, Kanna and Justo. Today also it is quite relevant. So we used to hear as a news. When I entered PWD, it is not exactly PWD, RDPR and the Irrigation Department jointly, when I was recruited as an assistant engineer in Government of Karnataka, I got the opportunity to work in almost all the departments. Right now, I am working as a CPO in PWD. That is, we are in charge of Karnataka State Highway Improvement Project. But quite often, I personally refer a lot of books. I interact with a lot of engineering fraternity. My inspiration is Mr. Veer Raghavan sir. So he is inspired by CEG.Justo sir. Really, I am thankful. I am blessed to be here in this 6th series of endowment lecture to give him a respect, what we owe to him. It is not only owing to him, we have to do a lot in the field. See, friends, at present, if you see Bangalore, it is a chaos in traffic. Since 1.5 years, I'm here. Earlier, I have served in North Karnataka, basically. Once I entered Bangalore, I felt so, today also I feel, whenever I move on the traffic, roads, I don't think I always think that I'm not at all an engineer. We are doing nothing. See, such a huge congestion in Bangalore. Everybody, all engineers, not only engineers, every human being is fed up with this traffic congestion. You know that, Bangaloreans especially. If you are there in US, if you are there in Delhi, if you are there outside, everybody speaks about Bangalore. Bangalore is beautiful, no doubt about it. At the same time, what are the problems we are facing right now? It is a really Herculean task to overcome all those problems. Friends, I shouldn't take much time on these Bangalore issues, but today burning issues are being discussed. And experts are here, we all engineers, we should lead. We should lead the country, not only with respect to infrastructure, with respect to everything. See, engineering is, in the past also, we have taken degrees like BE or MS, whatever, ME. But there were, olden days, there were no degrees, but they have built beautiful roads, they have built beautiful monuments, buildings. They have given us the best of the best infrastructure. Why these issues today? We have failed. Our vision is not correct, according to me. As a visionary engineer, except we inspire from M. Vishweshwaraya's works, but what we are practicing today, it is totally not relevant. What is engineering right now? What exactly civil engineering? I think always ask this question. What is this? All ills of the society. Civil engineering, civil itself is a part of civilization. We civil engineers are part of civilization, friends. We should contribute honestly, with a clean mind, clean heart. If you are honest to your work, definitely we can give best product. But where we are failing, civil engineering is not only purely engineering, it is a sheer common sense. In the past, so many people have built so many buildings. They were not truly engineers like what we have degrees. We have possessing degrees of MTech, MSc, PhD, whatever. But they have contributed a lot. Today, our contribution is not enough. So friends, think twice. It is a sheer common sense, but common sense is most uncommon to majority. Being a civil engineer, we should be proud to draw inspiration from Justo sir. Like a lot of IIT professors are here. Veer Raghavan sir has served in IIT Madras. I have got friends. I speak only about why infrastructure we are failing due to population, due to vehicle population, and unplanned towns, unplanned cities, no land plan properly done. So where to catch, how to catch? Of course, in the government, I shouldn't speak that, but we have to. So this civil engineering is basically common sense. I call it as a knowledge of common sense. Second knowledge, what we should possess, it is technical knowledge. We all know that where steel has to be put in tension, where concrete has to be poured. Everybody knows that is a little technical knowledge. Third knowledge is very, very important. It should be perfect knowledge. What you are doing, what you are giving, you should think, visualize. Let it be a building, let it be whatever, like infrastructure. We should have all three knowledges. Knowledge of common sense, I call it. It is a little technical knowledge. Third is a perfect knowledge. Who is perfect? One more question I ask usually. It is God is only perfect. Friends, think differently. Whatever as an infrastructure we are providing to our own people, it is a contribution to society. Ultimately, you are part and parcel of society. So we draw a lot of information, knowledge from nature. You adopt, practically adopt. See that sustainability will automatically come. Now this is across the globe, everybody is speaking sustainability. Everybody is speaking about climate change. and climate resilient structures. But we engineers, we should lead them. And see, non-engineering people are speaking much about engineering, but we people are not talking anything about engineering, being engineers. That is really very hurts, it really hurts me. Because common man is speaking a lot about engineering field, but what about we? We are unable to present ourselves properly. That is our weakness. Friends, this endowment lecture should, of course, we are very small gathering. I really feel proud to be part of engineering, especially civil engineering field. I love this profession. See, it is all your mindset. It is all your mindset. How you work, how you plan, how you execute, how you maintain. That all four, it should be like, right now one more issue is coming like circular economy. All same thing, we were all self-reliant in the past. India used to contribute around 30% of the world GDP prior to 100 years. But where we stand today, of course we are progressing very fast, it is not enough, but not in a right direction, quality-wise, quantity-wise. Think on those lines, friends. Of course, I don't want to take much on this, time on this because it is an inauguration session. I just want to tell you, K-Ship, what we are doing. See, we take funds from, right now, Asian Development Bank, around $346 million as a loan, out of $655 million total project cost. There, to get a funding from external agencies like World Bank or Asian Development Bank, we have to have a finance plus criteria in all our projects. So finance plus criteria, of course, we can, what is that finance plus? We have to be systemic. I mean, like transformation impact should be there for any projects we take up, especially in Karnataka State Highway. We are upgrading state highways, right now around 419 kilometers. There, we have got a scope to have best practices across the globe to bring into my state. So they have brought in, our fast engineers have done a wonderful job. So in that 419 kilometers, Karnataka government is doing a road safety audit for 17,481 kilometers. We have completed road safety audit for core road network of state highways and MDRs in Karnataka. Out of 35,000 odd kilometers we have selected as core road network, out of which around 17,481 kilometers is audited for road safety. Why we have done it? See, there you might have gone through IRAP. IRAP has come out with the statistics. Around 3,700 people are killed on the roads across the globe every day in 24 hours. So if you see Karnataka, India's analysis, in India alone, in 24 hours, 465 people are killed on the roads. This is one part. What about the bereaved family of the person who is killed on the roads? Think on those lines. Why these deaths on the roads? Everybody is blaming civil engineers. It is not correct. 3,700 people are killed every day. It comes to around 13.65 lakhs people are killed every year. 1,70,000 people are killed on our roads every year in India alone. In 13.65 lakhs, it is 70 to 80% are killed in, 70 to 80% in developing countries. So where we stand, if you see the pandemic, if you see the deaths due to various diseases, it is much, much less. So traffic safety, we talk road safety. Many people, there is a issue. A lot of people are, scolding engineers. All roads are leading for accidents. It is not correct. True engineer thinks it is a traffic management. Traffic engineering should be dealt, not civil engineering or road engineering itself alone, because a lot of statistics is there. You just think on those deaths on our roads. Around 5 crore people are injured across the globe every year. It is phenomenal due to our roads. 70 to 80% in developing countries. How to address this menace? Actually think. So giving infrastructure is one part. Second part, how to maintain also. So every product, whenever it is a market-driven product, right now it is market-driven, materials are coming in the market. All market-driven, all profit-oriented. So they give, their life usage period, everything, etc., etc. But in our civil engineering, whatever products like bridge or roads, we are not defining, we are not giving any disclaimer. Terms and conditions should apply. See, if a person rides with a 200 kilometer per hour, he's zooming like a 200 kilometer per hour, how my road will sustain or road will create a friction or traction to control the vehicle. Something has to be done in this area also. Because see, my roads are designed for 80 kilometer or 120 kilometer. Why you are allowing, the vehicles, we have to address even industrial houses who are building vehicles also for our Indian conditions. India is a population, it is 140 plus crores. Around 80 crores vehicle population also. It is going very fast. Think on those lines, think on the, ills what we are creating. It is a byproduct. It is not we are creating, but we are very much interested, we all engineers are very much interested to give a best product. But what product is giving results, they are speaking in other way. Think on those lines and come out with, I'm giving a thought, food for your thought. See why traffic engineering, traffic safety should be civil engineers' responsibility. Next question I will ask this, even in international conference also I have raised this issue. If traffic management is in my hand, then I could have dealt it differently. I'm giving this issue to you, please think on that. I'm really happy to be here with V. Raghavan sir, and I'm thankful to Ratnakar Reddy. He came to me and he gave me opportunity. Actually, he wanted to me in this panel discussion. Due to my other engagements, I said I will come for inauguration. Really, friends, you are really doing justice to Bangalore and the Bangalore engineering fraternity. To remember, give credit. What Justo sir has given to us. See, tried, tested, proven. Literature is with us. So how to handle? See, there's a big gap. Right now, we have got a lot of things on our fingertips with the internet, IoT. All people are artificial, AI, ML, everything is there. But don't go with that. Civil engineering is not like that. We should be different. Every civil engineer, every engineer in this room, you can create a new world, a beautiful world. I wish this association of Bangalore University Highway Engineering alumni will go a long way. They will contribute a lot, and that is what we can give respect to our Justo sir. Really, I'm thankful to all the team of Alumni Association of Bangalore University Highway Engineering. Thank you, friends, giving me opportunity and to be here with you all. I really privileged, I'm really blessed to be with you all because I love my civil engineering. Thank you one and all.
Thank you, sir, for that wonderful insight. And then definitely there are key takeaways from whatever you have done while addressing the gathering. And then sure that this will also put up a small spark because we see many youngsters here. So I'm sure that this will also help. I request Shri Lokesh to do the token of appreciation to Shri Shankar Gowda F. Patil, sir. Thank you, Lokesh. Now I request Dr. B.S. Prahalad, sir, that is EIC, BBMP, he is also one of the eminent engineer, to address the gathering. Sir, please.
ಎಲ್ಲರಿಗೂ ಈ ಶುಭ ಸಂಜೆಯ ಶುಭಾಶಯಗಳು. ವೇದಿಕೆ ಮೇಲಿರುವಂತಹ ಪ್ರೊಫೆಸರ್ ವೀರ ರಾಘವನ್ ಅವರೇ, ನಮ್ಮ ಕರ್ನಾಟಕ ಕೆಶಿಪ್ ಮುಖ್ಯ ಯೋಜನಾಧಿಕಾರಿಗಳೇ ಶಂಕರಗೌಡ ಪಾಟೀಲ್ರವರೇ, ಈ ಒಂದು ಸಂಸ್ಥೆಯ ಸೆಕ್ರೆಟರಿ ಆದಂತಹ ಶ್ರೀ ರತ್ನಾಕರ್ ರೆಡ್ಡಿ ಅವರೇ, ವೇದಿಕೆಯ ಮುಂಭಾಗದಲ್ಲಿರುವಂತಹ ನನ್ನ ಡಾಕ್ಟರೇಟ್ ಮಾಡೋದಕ್ಕೆ ಗೈಡ್ ಮಾಡಿದಂತಹ ಜಯ ಶಿಂಗನ್ಮಕ್ಕಿಯವರವರೇ, ಅದೇ ರಾಸ್ತಾ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ನಲ್ಲಿ ಆ್ಯಕ್ಟಿಂಗ್ ಪ್ರಿನ್ಸಿಪಾಲ್ ಆಗಿರುವಂಥ ಪ್ರೊಫೆಸರ್ ಕವಿತಾರವರೇ, ನನ್ನ ಬೃಹತ್ ಬೆಂಗಳೂರು ಮಹಾನಗರ ಪಾಲಿಕೆಯಲ್ಲಿ ತಾಂತ್ರಿಕ ಸಲಹೆ ಸಮಿತಿಯ ಸದಸ್ಯರಾದ ಶ್ರೀ ಪ್ರೊಫೆಸರ್ ಆಂಜನೇಯಪ್ಪರವರೇ, ನಮ್ಮ ಇಂಜಿನಿಯರಿಂಗ್ ಫೆಡರೇಷನ್ನ ಅಧ್ಯಕ್ಷರಾದಂತಹ ಶ್ರೀ ನಾಗರಾಜ್ರವರೇ, ನನ್ನ ಬಾಸ್ ಆಗಿದ್ದಂತಹ ಮತ್ತು ಬೃಹತ್ ಬೆಂಗಳೂರು ಮಹಾನಗರ ಪಾಲಿಕೆಯಲ್ಲಿ ಪ್ರಧಾನ ಅಭಿಯಂತರಾದಂತಹ ಇಂಜಿನಿಯರ್ ಚೀಫ್ ಆದಂತಹ ಶ್ರೀ ಜಯಪ್ರಸಾದ್ರವರೇ, ನನ್ನ ಮಾರ್ಗದರ್ಶಕರು ಆದಂಥ ಮತ್ತು ರಾಮಚಂದ್ರರವರೇ ಮತ್ತು ಎಲ್ಲ ಗಣ್ಯರೇ, ಈ ಒಂದು ಇನ್ಸ್ಟಿಟ್ಯೂಷನ್ ಆಫ್ ಇಂಜಿನಿಯರ್ಸ್ ಬರೋದಕ್ಕೂ ಮತ್ತು ಪ್ರೊಫೆಸರ್ ಜಸ್ಟೋರವರ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೂ ಬರೋದಕ್ಕೂ ಎರಡಕ್ಕೂ ನಾನು ಋಣಿ ಇದ್ದೀನಿ. ಇಲ್ಲೇ ನಾನು ಇನ್ಸ್ಟಿಟ್ಯೂಷನ್ ಆಫ್ ಇಂಜಿನಿಯರ್ಸಲ್ಲಿ AMI ಸೆಕ್ಷನ್ A ಸೆಕ್ಷನ್ B ಎರಡು ಪಾಸ್ ಮಾಡಿ 1991 ಜಾಯ್ನ್ ಆದೆ. ಆವಾಗ AMIಗೆ ಭಾಳ ಜಾಯ್ನ್ ಆಗಬೇಡ, ಓದೋದಕ್ಕಾಗಲ್ಲ, BE ಸೇರಿಬಿಡು ಅಂತ. ನನಗೇನೋ ಒಂಥರ ಹಠ, BE ಸೇರೋದು ಬೇಡ, AMI ಮಾಡಿ ಕೆಲಸ ಮಾಡಿಕೊಂಡು ಇದು ಮುಗಿಸೋಣ ಅಂತ, ಡಬಲ್ ಇದಂತ. ಆಗ ಎಲ್ಲರೂ ಹೇಳ್ತಾಯಿದ್ರು ಆಗೋದಿಲ್ಲ ಮಾಡೋದಿಲ್ಲ ಅಂತ. ಸೊ ಗಾಡ್ಸ್ ಗ್ರೇಸ್ 3.5 ಇಯರ್ಸಲ್ಲಿ ನಾನು AMI ಮುಗಿಸ್ದೆ. ಆಮೇಲೆ ತಿರ್ಗಾ 96 ಅಸಿಸ್ಟೆಂಟ್ ಇಂಜಿನಿಯರ್ ಆದೆ. ಇನ್ನೊಂದು ವಿಚಾರವಾಗಿ ಪ್ರೊಫೆಸರ್ ಜಸ್ಟೋ ಅವ್ರಿಗೆ ನಾನು ಯಾಕೆ ಋಣಿ ಅಂತ ಹೇಳಿದೆ ಅಂತಂದರೆ, ನಾನು ಇನ್ಹೌಸ್ BBMPಯಲ್ಲಿ ಅಸಿಸ್ಟೆಂಟ್ ಎಕ್ಸಿಕ್ಯೂಟಿವ್ ಇಂಜಿನಿಯರ್ ಆಗಿ ಕೆಲಸ ಮಾಡ್ತಾ ಇದ್ದಾಗ ಒಂದು ನಿಮ್ಮ ಬೃಹತ್ ಬೆಂಗಳೂರು ಮಹಾನಗರ ಪಾಲಿಕೆಯಲ್ಲಿ ಇಂಜಿನಿಯರ್ಸ್ಗೆ ತಾಂತ್ರಿಕ ಕೌಶಲ್ಯ ಇಲ್ಲ, ಅವರಿಗೆ ತರಬೇತಿ ಬರಬೇಕು, ಅವರು ಆ ತರಬೇತಿಯಿಂದ ಹೆಚ್ಚಿನ ಒಂದು ಸೇವೆಗೆ ಅನುಕೂಲ ಆಗ್ತದೆ ಅಂತ ಹೇಳಿ 6 months to 8 months ನೀವು ಫುಲ್ ಅಂದರೆ 100% ನೀವು ಟ್ರೈನಿಂಗ್ ಪ್ರೋಗ್ರಾಮ್ ಕಳಿಸ್ಬೇಕು, ಅವರಲ್ಲಿ ಓದಬೇಕು, ಓದಿ ವಾಪಸ್ ಬರಲಿ, ತಿರ್ಗಾ 6 ತಿಂಗಳಲ್ಲಿ ಏನೂ ತೊಂದರೆ ಆಗಲ್ಲ ಅಂತ ಹೇಳಿ ಜಸ್ಟೋರವರು BBMP ಅಡ್ಮಿನಿಸ್ಟ್ರೇಷನ್ಗೆ ಕನ್ವಿನ್ಸ್ ಮಾಡಿದ್ರು. ಆ ಒಂದು ಫಸ್ಟ್ ಟೀಮಲ್ಲಿ ನಾನು ಜಾಯ್ನ್ ಆದೆ. ಸೊ ಆ ಜಾಯ್ನ್ ಆದಾಗ 6 months ಓದ್ತಾ ಹಾಗೆಯೇ ನನಗೆ ಇಂಟ್ರೆಸ್ಟ್ ಬಂತು. ಅದೇ ಟೈಮಲ್ಲಿ ಜಸ್ಟೋರವರು ಲ್ಯಾಟ್ರಲ್ ಎಂಟ್ರಿ ಟು MTech ಹೈವೇಸ್ ಅಂತ ಒಂದು ತಂದರು. ಸೊ ಏನೋ ಒಂದು ಅದೃಷ್ಟ ನನಗೂ. ಸೊ ಐ ಜಾಯಿಂಡ್ MTech ಕೋರ್ಸ್. ಅಗೇನ್ ಐ ಕಂಟಿನ್ಯೂಡ್ ಫಾರ್ 1.5 years. ಬೇರೆಯವರೆಲ್ಲ 6 ತಿಂಗಳಿಗೆ ಟ್ರೈನಿಂಗ್ ಮುಗಿಸ್ಕೊಂಡು BBMPಗೆ ಹೋದರೆ, ನಾನು ಇನ್ನೂ 1.5 ವರ್ಷ ಅಲ್ಲಿ ತಿರ್ಗಾ ಓದಿ ಇನ್ಹೌಸ್ MTech ಮಾಡಿದೆ. ಸೊ MTech ಆದಮೇಲೆ ಏನೋ ಆ ಒಂದು ಎಜುಕೇಷನ್ನು ತಿರ್ಗಾ ಗಟ್ಟಿಯಾಗಿ ಹಿಡ್ಕೊಂತು. 2011 ಮತ್ತೆ PhDಗೆ ಎನ್ರೋಲ್ ಮಾಡಿದೆ. ಬಟ್ 2011 ಆದಾಗ ಅಷ್ಟೊತ್ತಿಗೆ ಎಕ್ಸಿಕ್ಯೂಟಿವ್ ಇಂಜಿನಿಯರ್ ಆಗಿದ್ದೆ, ಜವಾಬ್ದಾರಿಗಳು ಜಾಸ್ತಿನೂ ಆಗಿತ್ತು. ಐ ಟುಕ್ ಅಟ್ಲೀಸ್ಟ್ 13 years ಫಾರ್ ಕಂಪ್ಲೀಟಿಂಗ್ ಮೈ PhD. ಸೊ ಆದ್ರೂ ಐ ವಾಸ್ ಅ ಸ್ಟೂಡೆಂಟ್ ಅಂತ ಹೇಳ್ಕೊಳ್ಳೋದಕ್ಕೆ ಖುಷಿ ಆಗ್ತದೆ. ಐ ವಾಸ್ ಆಲ್ವೇಸ್ ವಿತ್ ದಿ ಕರೆಂಟ್ ಅಫೇರ್ಸ್ ಆಫ್ ದಿ ಸಿವಿಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಅಂತ ಹೇಳ್ತಾ, ಇವತ್ತು ಒಳ್ಳೆ ಸಬ್ಜೆಕ್ಟು. ಜಸ್ಟೋ ಅವರು ನಿಜವಾಗ್ಲೂ ಖುಷಿ ಪಡ್ತಾರೆ, ಅವ್ರ ಆತ್ಮಕ್ಕೆ ಶಾಂತಿ ಸಿಗುತ್ತೆ, ಅವ್ರಿಗೆ ಆತ್ಮಕ್ಕೂ ಖುಷಿನೂ ಆಗ್ತದೆ. ಈ ಒಂದು ಸಿವಿಲ್ ಇಂಜಿನಿಯರ್ಸು ಅವರ ಹೆಸರಿನಲ್ಲಿ ಒಂದು ಅವರು ಕೊಟ್ಟಂತಹ ಮಾರ್ಗ ನಾವು ಹಿಡಿದು ಹೆಚ್ಚು ತಂತ್ರಾಂಶವನ್ನು ಪಡಿತಾ ಇದ್ದೀವಿ ಅನ್ನೋದು ಮತ್ತು ಎಲ್ಲ ಜನ ಸೇರಿರೋದು ಅವ್ರಿಗೆ ನಿಜವಾಗ್ಲೂ ಖುಷಿ ಆಗ್ತದೆ. ಈ ಒಂದು ವಿಚಾರದಲ್ಲಿ ಹೇಳಬೇಕು ಅಂತಂದರೆ, ಇವತ್ತು ಬೃಹತ್ ಬೆಂಗಳೂರು ಮಹಾನಗರ ಪಾಲಿಕೆಯಲ್ಲೂ ನಮ್ಮ ಶಂಕರಗೌಡ ಪಾಟೀಲ್ ಅವರು ಹೇಳ್ತಾಯಿದ್ರು, ಬೆಂಗಳೂರು ಹ್ಯಾಸ್ ಬಿಕಮ್ ಖ್ಯಾಟಿಕ್ ಅಂತ. ನಿಜನೇ. ಏನಾಗ್ತಾ ಇದೆ, ಪ್ರತಿ ಸಾರಿನೂ ಏನಾದರೂ ಒಂದು ಯೋಜನೆನ ಕಾರ್ಯರೂಪಕ್ಕೆ ತರಬೇಕಾದಾಗ ಅದಕ್ಕೆ 108 ಜನ ಮೂಗು ಮುರಿಯೋರೇ ಆಗ್ತಾ ಇರ್ತಾರೆ. ಹಾಗೆ ಮಾಡಬಾರ್ದು ಯಾಕೆ, ಹೀಗೆ ಮಾಡಬಾರ್ದು ಯಾಕೆ, ಅದನ್ನು ಮಾಡ್ಬೋದು, ಇದನ್ನು ಮಾಡ್ಬೋದು, ವಾಕಬಿಲಿಟಿ ಮಾಡ್ಬೋದು, ನಾನ್ ಮೋಟರೈಸ್ ಟ್ರಾನ್ಸ್ಪೋರ್ಟ್ ತರ್ಬೋದು, ಮತ್ತು ಅವ್ರದ್ದೇ ಆದ ಒಂದು ಚಿಂತನೆಗಳಲ್ಲಿ ಕಾಲಹರಣ ಆಗ್ತಾಯಿದೆ ಅಂತ ಹೇಳೋದಕ್ಕೆ ಇಷ್ಟಪಡ್ತೀನಿ. ಇದೇ ರೀತಿಯಲ್ಲಿ ನಾವು 2001 ಅಂತ ಹೇಳ್ತೀನಿ. 2001 ವಿ ವೇರ್ ಅಬೌಟ್ 80 lakhs, ಅಂದರೆ 8 million ಅಂತ ಹೇಳ್ಬೋದು. ಇವತ್ತು 2001 2020ಗೆ ವಿ ಆರ್ ಆಲ್ರೆಡಿ 14 million, ಅಂದರೆ 60 ಲಕ್ಷ ಜನ ಈ ಬೆಂಗಳೂರು ಬಂದು ವಾಸ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಬೆಂಗಳೂರು ಟ್ರಾಫಿಕ್ ಬಗ್ಗೆ ಬೈತಾರೆ, ಎಲ್ಲನೂ ಇದೆ, ಆದರೆ ಬೆಂಗಳೂರು ನಗರನ ಹೊಗಳ್ತಾರೆ. ಅದರಿಂದಾಗಿ ಇನ್ಫ್ಲಕ್ಸ್ ಟು ದಿ ಬೆಂಗಳೂರು ಜಾಸ್ತಿನೂ ಆಗ್ತಾಯಿದೆ. ಅಂದರೆ ಇಟ್ ಇಸ್ ಬಿಕಮಿಂಗ್ ಚಾಲೆಂಜ್. ಡೇ ಬೈ ಡೇ ಏನು ಇನ್ಫ್ರಾಸ್ಟ್ರಕ್ಚರ್ ಸ್ಟ್ರೈನ್ ಆಗ್ತಾಯಿದೆ. ಇನ್ಫ್ರಾಸ್ಟ್ರಕ್ಚರ್ನ ಡೆವಲಪ್ ಮಾಡೋ ಟೈಮಲ್ಲಿ ಅವ್ರದ್ದೇ ಆದ ಚಿಂತನೆಯಲ್ಲಿ ತುಂಬ ವಿರೋಧ ಬರ್ತದೆ. ಆ ಒಂದು ವಿರೋಧನೆಲ್ಲ ನಾವು ತಗೊಂಡು ಸಸ್ಟೈನಬಿಲಿಟಿ ಅಂತ ಒಂದು ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ದಿಸ್ ಇಸ್ ಎ ವೆರಿ ಗುಡ್ ಸಬ್ಜೆಕ್ಟು. ಅರ್ಬನ್ ರೋಡ್ಸ್, ಮೊಬಿಲಿಟಿ ಆ್ಯಂಡ್ ಸಸ್ಟೈನಬಿಲಿಟಿ. ವಿ ನೀಡ್ ಮೊಬಿಲಿಟಿ ಆ್ಯಸ್ ವೆಲ್ ಆಸ್ ಸಸ್ಟೈನಬಿಲಿಟಿ ಅಂತ ಏನು ಇವತ್ತು ಸಬ್ಜೆಕ್ಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ದಟ್ ಇಸ್ ಎ ವೆರಿ ಗುಡ್ ಸಬ್ಜೆಕ್ಟು. ಇವತ್ತು ಬೆಂಗಳೂರು ನಗರದಲ್ಲಿ ನಾವು ಒಂದು ಟ್ರಾಫಿಕ್ನ ಕಡಿಮೆ ಮಾಡಬೇಕು, ಲೆಸ್ ಟ್ರಾಫಿಕ್ ಮೋರ್ ಹ್ಯೂಮನ್ ಲೈಫ್ ಅಂತ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ತೊಗೊಂಡು ಏನು ಮಾಡಬೇಕು ಅಂತ ನಾವು ಕಳೆದ 2 ವರ್ಷದಿಂದ, ನಾನು ಇಂಜಿನಿಯರಿಂಗ್ ಚೀಫ್ ಆಗಿ ಚಾರ್ಜ್ ತೊಗೊಂಡೋದಾಗಿಂದ ಇದೇ ಮೊಬಿಲಿಟಿ ಬಗ್ಗೆನೇ ತುಂಬ ಚರ್ಚೆ ಆಗ್ತಾಯಿತ್ತು. ಈ ಮೊಬಿಲಿಟಿ ಯಾವ ರೀತಿಯಲ್ಲಿ ಇಂಪ್ರೂವ್ ಆಗಬೇಕು ಅವೆಲ್ಲ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದ್ದಾಗ, ಈಗ ವಿ ಹ್ಯಾವ್ ಎ ಡಿಫ್ರೆಂಟ್ ಮೋಡ್ ಆಫ್ ಮೊಬಿಲಿಟಿ. ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ ಎಕ್ಸ್ಪರ್ಟ್ಸ್, ಡೊಮೇನ್ ಎಕ್ಸ್ಪರ್ಟ್ಸ್ ಆ್ಯಂಡ್ ಹೌ ವಿ ಹ್ಯಾವ್ ಟು ಗೋ ಫಾರ್ವರ್ಡ್ ಅಂತ, ವೇ ಫಾರ್ವರ್ಡ್ ಏನು ಅಂತ ಅವ್ರು ಹೇಳ್ತಾ ಇದ್ರು. ಫುಡ್ ಫಾರ್ ಥಾಟ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ರಲ್ಲ, ಹಾಗೆ ಆ ಫುಡ್ ಫಾರ್ ಥಾಟ್ನ ನಾವು ತೊಗೊಂಡು ವಿ ಅಪಾಯಿಂಟೆಡ್ ಸಮ್ ಕನ್ಸಲ್ಟೆಂಟ್ಸ್ ಹೂ ಇನ್ ಟರ್ನ್ ಡಿಡ್ ಎ ಪ್ರೀ-ಫಿಸಿಬಿಲಿಟಿ ಸ್ಟಡಿ ಫಾರ್ ಟ್ರಾಫಿಕ್ ಇಶ್ಯೂಸ್. ಆ ಒಂದು ವಿಚಾರದಲ್ಲಿ ಇವತ್ತು ಏನು ನಾಟ್ ಓನ್ಲಿ ನಾನ್ ಮೋಟರೈಸ್ ಟ್ರಾನ್ಸ್ಪೋರ್ಟಿಂದ ಹಿಡಿದು ಲಾಸ್ಟ್ ಮೈಲ್ ಕನೆಕ್ಟಿವಿಟಿಯಿಂದ ತೊಗೊಂಡು ಆಮೇಲಿಂದ ಮಾಸ್ ಟ್ರಾನ್ಸ್ಪೋರ್ಟ್, ಮೆಟ್ರೋ, BMTC ಮತ್ತು ಏನು ಇವತ್ತು ತಿರ್ಗಾ ಸಬರ್ಬನ್ ರೈಲ್ ಅಂತ ಬರ್ತಾ ಇದೆ, ಅದ್ರ ಜೊತೆಗೆ ವಿ ನೀಡ್ ಟು ಕ್ಯಾಪ್ಚರ್ ಆಲ್ ಸೆಕ್ಷನ್ ಆಫ್ ದಿ ಸೊಸೈಟಿ. ಇಟ್ ಈಸ್ ನಾಟ್ ದಟ್ ಕಾಮನರ್ಸ್ ಆಗಿ ಅಲ್ಲಿ ಹೋಗ್ತಾರೆ, ಮತ್ತು ಟ್ರೈನ್ ಇದು ಕಾರ್ಗಳಿಗೆ ಮಾಡ್ತೀರಾ, ಟನಲ್ಸು ಮತ್ತು ಇನ್ನೇನೋ ಇದಕ್ಕೆ ಮಾಡ್ತೀರಾ ಅಂತಂದಾಗ ವಿ ನೀಡ್ ಟು ಹ್ಯಾವ್ ಮಲ್ಟಿ ಮೋಡಲ್ ಮೊಬಿಲಿಟಿ ಸಿಸ್ಟಮ್ ಅಂತ ಬೆಂಗಳೂರು ನಗರದಲ್ಲಿ. ಯಾಕಂದರೆ ಇವತ್ತು ಬೆಂಗಳೂರು ನಗರ 2030ಕ್ಕೆ ತಿರ್ಗನೇ ನಮ್ಮದು ಏನು 140 lakhs ಅಂತ ಏನು ಹೇಳ್ತೇವೆ, 14 million ಅಂತ ಹೇಳಿದೆ, ಅದು 20 million ತನಕ ಹೋಗ್ತದೆ. ಅದು 2 crores ಅಂದರೆ 30% ಆಫ್ ದಿ ಕರ್ನಾಟಕ ಪಾಪ್ಯುಲೇಷನ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಸ್ಟೇಯಿಂಗ್ ಇನ್ ಬ್ಯಾಂಗ್ಳೂರ್ ಅಂತ ಒಂದಿದೆ. ಆಮೇಲಿಂದ ಇವತ್ತು ಗ್ರೇಟರ್ ಬೆಂಗಳೂರು ಅಂತ ಮಾಡ್ತಾ ಇರೋದು ಅದಕ್ಕೇ. ಕೋರ್ ಏರಿಯಾದಲ್ಲಿ ಕಾಂಪ್ಯಾಕ್ಟ್ ಆಗೋಕ್ಕಿಂತನೂ ಬ್ಯಾಂಗ್ಳೂರ್ ಅಂತ ಅದಕ್ಕೊಂದು ಹೆಸರು ಕೊಟ್ಟು ಅಟ್ಲೀಸ್ಟ್ ಔಟ್ಸ್ಕರ್ಟ್ಸಲ್ಲಾದರೂ ಉಳ್ಕೊಂಡು ಕಾಲ್ಕುಲೇಷನ್ ಆಗ್ತದೆ ಅಂತ ಅಂದ್ಕೊಳ್ತಾ ಇದ್ದೀವಿ. ಅದಕ್ಕೂ ಲೆಕ್ಕ ತೊಗೊಂಡ್ರೆ ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು 250 lakhs, ಅಂದರೆ 25 million ಪಾಪ್ಯುಲೇಷನ್ ವಿಲ್ ಬಿ ಇನ್ ಬ್ಯಾಂಗ್ಳೂರ್ ಸಿಟಿ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ಹಾಗಾಗಿ ನಾವು ಮುಂದಿನ 5 ವರ್ಷಕ್ಕೆ ಒಂದು ರೋಡ್ ಮ್ಯಾಪ್ ಅಥವಾ ಬ್ಲೂ ಪ್ರಿಂಟ್ ಅಂತ ಮಾಡ್ತಾಯಿದ್ದೀವಿ. ಆ ಬ್ಲೂ ಪ್ರಿಂಟ್ ಪ್ರಕಾರವಾಗಿ ಮೊದಲನೇದಾಗಿ ಏನು ಅರ್ಸ್ಟ್ವೈಲ್ ನ್ಯಾಷನಲ್ ಹೈವೇಸ್ ಅಂತ ಕರಿತಾ ಇದ್ವಿ, ಇವತ್ತು NH7 ಅಂತ ಏನು ಹೇಳ್ತೀವಿ, ಅದು ನಾರ್ದನ್ ಸೈಡ್ ಬಳ್ಳಾರಿ ರೋಡ್ ಆಗಿದೆ, ಸದರ್ನ್ ಸೈಡು ಹೊಸೂರು ರೋಡ್ ಅಂತ ಇದ್ವಿ. ಸೊ ದೋಸ್ 2 ನ್ಯಾಷನಲ್ ಹೈವೇಸ್, ಅರ್ಸ್ಟ್ವೈಲ್ ನ್ಯಾಷನಲ್ ಹೈವೇಸ್ ವಿಚ್ ವಾಸ್ ರನ್ನಿಂಗ್ ವಿತಿನ್ ದಿ ಸಿಟಿ ಆರ್ ಟು ಬಿ ರೀಕನೆಕ್ಟೆಡ್ ಅಂತ. ಅದೇ ಥರನೇ ನಮ್ಮ ಏನು ನ್ಯಾಷನಲ್ ಹೈವೇ ನಂಬರ್ 4 ಮತ್ತು ಮೈಸೂರು ರೋಡ್ ಅಂತ ಏನಿದೆ ಅದನ್ನು ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು. ಸೊ ನಾರ್ತ್ ಸೌತ್ ಆ್ಯಂಡ್ ಈಸ್ಟ್ ವೆಸ್ಟ್ ಕಾರಿಡಾರ್ಸ್ ಅಂತ 2 ಮಾಡಿ ವಿ ನೀಡ್ ಟು ಸಸ್ಟೈನ್ ದಿ ಕೋರ್ ಏರಿಯಾ ಆಫ್ ಬ್ಯಾಂಗ್ಳೂರ್ ಆಲ್ಸೋ. ಏನು ಡಿಕೆ ಆಗ್ತಾ ಇದೆ ಇವತ್ತು ಕೋರ್ ಏರಿಯಾ ಆಫ್ ಬ್ಯಾಂಗ್ಳೂರ್, ಅದನ್ನು ಸಸ್ಟೈನಬಲ್ ಡೆವಲಪ್ಮೆಂಟ್ ಆಗಬೇಕು, ಅದನ್ನು ಲೀವಬಿಲಿಟಿನ ಇಂಪ್ರೂವ್ ಮಾಡಬೇಕು ಅನ್ನೋ ಒಂದು ದೃಷ್ಟಿಯಿಂದ ಆ ಒಂದು ಟನಲ್ ಪ್ರಾಜೆಕ್ಟ್ ಮಾಡಿದೆ. ಅದೇ ರೀತಿಯಲ್ಲಿ ಇವತ್ತು ಮೆಟ್ರೋ ಪ್ರಾಜೆಕ್ಟ್ ಆಗ್ತಾಯಿದೆ. ಮೆಟ್ರೋ ಪ್ರಾಜೆಕ್ಟ್ ಜೊತೆಗೆ ಬೆಂಗಳೂರು ನಗರದಲ್ಲಿ ಏನು ಮಾಡ್ತಾಯಿದ್ದೀವಿ ಅಂದರೆ ಟ್ರಾನ್ಸಿಟ್ ಓರಿಯೆಂಟೆಡ್ ಡೆವಲಪ್ಮೆಂಟ್ ಅಂತ. ಪ್ರತಿ ನಮ್ಮ ಮೆಟ್ರೋ 1 ಕಿಲೋಮೀಟರ್ ಏನಿದೆ, ಆ 1 ಕಿಲೋಮೀಟರ್ ಆನ್ ದ ಐದರ್ ಸೈಡ್ ಆಫ್ ದಿ ಮೆಟ್ರೋ ಕಾರಿಡಾರ್ ಅಲ್ಲಿ FARನ ಜಾಸ್ತಿ ಮಾಡಿ ಹೈ ರೈಸ್ಡ್ ಬಿಲ್ಡಿಂಗ್ಸ್ ಆಗುವಂಥದ್ದು, ಮತ್ತು ಜನ ಈಟ್ ಆ್ಯಂಡ್ ಪ್ಲೇ ಆ್ಯಂಡ್ ವರ್ಕ್ ಅಂತ ಏನು ಹೇಳ್ತೀವಿ, ಸ್ಟೇ ಪ್ಲೇ ಆ್ಯಂಡ್ ವರ್ಕ್ ಅಂತ ಏನು ಹೇಳ್ತೀವಿ, ಆ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ನು ಬೆಂಗಳೂರು ನಗರಕ್ಕೆ ತರಬೇಕು ಅಂತ ಇದೆ. ಅದೇ ರೀತಿಯಲ್ಲಿ ಒಂದು ಏನು ರೇಡಿಯಲ್ ರೋಡ್ಸ್ ಟು ಬ್ಯಾಂಗ್ಳೂರ್ ಸಿಟಿ ಅಂತ ಇದೆ, ಆ ರೇಡಿಯಲ್ ರೋಡ್ಸ್ನಲ್ಲಿ ಇದು ಫ್ಲೈಓವರ್ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಅಬೌಟ್ 120 to 130 kilometers ಆಫ್ ಫ್ಲೈಓವರ್ಸ್ ಮಾಡಬೇಕು ಅಂತ ಇದೆ. ಅದ್ರ ಜೊತೆಗೆ ಇವತ್ತು ಸ್ಟಾರ್ ವಾಟರ್ ಡ್ರೈನ್ಸ್ ನಮ್ಮಲ್ಲಿ ಬೆಂಗಳೂರಿನಲ್ಲಿ 859 kilometers ಇದೆ. ಅದ್ರ ಪಕ್ಕದಲ್ಲಿ ಇವತ್ತು ಏನು ಬಫರ್ ಝೋನ್ ಅಂತ ನಾವು ಏನು ಕರಿತೀವಿ, ಇಟ್ ಈಸ್ ಜಸ್ಟ್ ಆನ್ ಪೇಪರ್ಸು. ಎಷ್ಟೊಂದು ಕಡೆ ಎನ್ಕ್ರೋಚ್ಮೆಂಟ್ ಆಗುವಂಥದ್ದು, ಅದನ್ನು ನಾವು ಡೆಮಾಲಿಷನ್ ಮಾಡೋದು ಅವೆಲ್ಲ ಮಾಡ್ತಾಯಿದ್ದೀವಿ. ಅದಕ್ಕೆ ವಿ ಹ್ಯಾವ್ ಟು ಇನ್ಕ್ರೀಸ್ ದಿ ರೋಡ್ ನೆಟ್ವರ್ಕ್ ಅಂತ ಹೇಳಿ ಆ ಬಫರ್ ಝೋನ್ಸ್ನು ಯೂಟಿಲೈಸ್ ಮಾಡಿಕೊಂಡು ನಾವು ರೋಡ್ಸ್ ಅಡಿಷ್ನಲ್ ರೋಡ್ ಲೆಂತ್ಸ್ನ ಇಂಪ್ರೂವ್ಮೆಂಟ್ ಮಾಡಬೇಕು ಅನ್ನೋದು. ಅದ್ರ ಜೊತೆಗೆ ಇವತ್ತು ಮೆಟ್ರೋ ಏನು ಎಲಿವೇಟೆಡ್ ಮೆಟ್ರೋ ಎಲ್ಲೆಲ್ಲಿ ಬರ್ತಾ ಇದೆ ಅಲ್ಲೆಲ್ಲ ನಾವು ವಿ ಶುಡ್ ಹ್ಯಾವ್ ಡಬಲ್ ಡೆಕ್ಕರ್ಸ್ ಸಿಸ್ಟಮ್ ಆಫ್ ರೋಡ್ ಅಂತ, ರೋಡ್ ಅಟ್ ಗ್ರೇಡ್ 1 ಆ್ಯಂಡ್ ಮೆಟ್ರೋ ಅಟ್ ಗ್ರೇಡ್ 2 ಅಂತ. ಆ ರೀತಿಯಲ್ಲಿ ಡಿಫ್ರೆಂಟ್ ವರ್ಕ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಈಗಾಗಲೇ ಪಬ್ಲಿಕ್ ಡೊಮೈನಲ್ಲಿ ನಾವು ಬಿಟ್ಟಿದ್ದೀವಿ. ಸೊ ದೀಸ್ ಆರ್ ಆಲ್ ದಿ ಪಾಯಿಂಟ್ಸ್ ವಿಚ್ ವಿ ಹ್ಯಾವ್ ಐಡೆಂಟಿಫೈಡ್ ಟು ಇಂಪ್ರೂವ್ ದಿ ಟ್ರಾಫಿಕ್ ಸಿಸ್ಟಮ್. ಏನು ಡಿಕಂಜೆಷನ್ಸ್ಗೆ ಆಫ್ ಬ್ಯಾಂಗ್ಳೂರ್ ಸಿಟಿ ಅಂತ ಏನು ತೊಗೊಂಡಿದ್ದೀವಿ, ಈ ಒಂದು ಸಿಸ್ಟಮಲ್ಲಿ ಮಾಡ್ತಾಯಿದ್ದೀವಿ. ಸೊ ಇದೆಲ್ಲದಕ್ಕೂ ಏನು ಇವರು ಮಾಡ್ತಾರಾ, ಆಗುತ್ತಾ ಆಗಲ್ವಾ, ವಾಟ್ ಈಸ್ ದಿ ಫೈನಾನ್ಷಿಯಲ್ ಸಿಸ್ಟಮ್ಸ್ ಅನ್ನೋದಕ್ಕೆ ವಿ ಹ್ಯಾವ್ ಗಾನ್ ಫಾರ್ ಇನ್ನೋವೇಟಿವ್ ಫೈನಾನ್ಷಿಯಲ್ ಸಿಸ್ಟಮ್ಸ್ ಅಂತ. ಇವಾಗ ಯಾರೇ ಒಬ್ಬರು ಮನೆ ಕಟ್ಟಬೇಕು ಅಂತಂದರೆ ಅವರು ಬ್ಯಾಂಕ್ನ ಅಪ್ರೋಚ್ ಮಾಡ್ತಾರೆ ಲೋನು, ಅದನ್ನು ಯಾರೂ ತಪ್ಪು ಅನ್ನೋಲ್ಲ. ಆದರೆ ವೆನ್ ವಿ ಅಪ್ರೋಚ್ to give infrastructure for Bangalore city, everybody will cry hue and cry. ಹಾಗಾಗಿ ಸೊ ವಿ ನೀಡ್ ಟು ಹ್ಯಾವ್ ಎ ಡಿಫ್ರೆಂಟ್ ಅಪ್ರೋಚ್ ಟುವರ್ಡ್ಸ್ ಬ್ಯಾಂಗ್ಳೂರ್ ಸಿಟಿ. ಇವತ್ತು ನಾವು ರಸ್ತೆ ಅಗಲೀಕರಣ ಮಾಡ್ತೀವಿ ಅಥವಾ ಇನ್ನೇನೋ ಮಾಡ್ತೀವಿ ಅಂತಂದರೆ ಇಟ್ ಈಸ್ ಇಂಪಾಸಿಬಲ್. ವಿ ನೀಡ್ ಟು ಫೈಂಡ್ ಡಿಫ್ರೆಂಟ್ ಮೆಥಡ್ಸು. ಆ ರೀತಿಯಲ್ಲಿ ನಾವು ಇನ್ನೋವೇಟಿವ್ ಫೈನಾನ್ಷಿಯಲ್ ಸಿಸ್ಟಮ್ಸಲ್ಲಿ ನಾವು ಮಾಡ್ತಾಯಿದ್ದೀವಿ. ಸೊ ಮುಂದಿನ ತಾವೆಲ್ಲ ಇವಾಗೆಲ್ಲ ಬಜೆಟ್ ಅನೌನ್ಸ್ಮೆಂಟ್ಸ್ ಎಲ್ಲ ತಾವು ನೋಡಿರ್ಬೋದು. ನೆನ್ನೆನೇ ಬಜೆಟ್ ಆಗಿದೆ. ಸೊ ದ ಗೌರ್ಮೆಂಟ್ ಆಫ್ ಕರ್ನಾಟಕ ಈಸ್ ಹೆಲ್ಪೆಂಟ್ ಟು ಇಂಪ್ರೂವ್ ದಿ ಇನ್ಫ್ರಾಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಬ್ಯಾಂಗ್ಳೂರ್ ಸಿಟಿ. ಇಫ್ ನಾಟ್ ಬ್ಯಾಂಗ್ಳೂರ್ ಸಿಟಿಯಲ್ಲಿ ಯಾರೂ ಇರೋದಕ್ಕೆ ಆಗಲ್ಲ ಅಂತ ಹೇಳ್ಬೋದು. ಇನ್ನೂ ಒಂದು 3 ವರ್ಷ ಈಗಲೇ ನೌ ಆರ್ ನೆವರ್ ಅನ್ನೋ ರೀತಿ ಆಗಿಬಿಟ್ಟಿದೆ. ಸೊ ಹಾಗಾಗಿ ಈ ಸಿವಿಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಈಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ನಮ್ಮ ಮುಖ್ಯವಾಗಿ ನಾನು ನನ್ನ ಸರ್ವಿಸಲ್ಲಿ ಏನು ನೋಡಿದೆ ಅಂತಂದರೆ, ಏನೇ ಒಂದು ಡೆವಲಪ್ಮೆಂಟಲ್ ಪ್ರೋಗ್ರಾಮ್ ಅಪ್ರೂವ್ ಆಗಬೇಕು ಅಂದರೆ ವಿ ನೀಡ್ ಟು ಕನ್ವಿನ್ಸ್ ದಿ ಅಡ್ಮಿನಿಸ್ಟ್ರೇಟರ್ಸ್. ಈ ಅಡ್ಮಿನಿಸ್ಟ್ರೇಟರ್ಸ್ನ ನಾವು ಕನ್ವಿನ್ಸ್ ಮಾಡಬೇಕು ಅಂದರೆ ನಮ್ಮ ಒಂದು ಯೋಜನೆಯ ಧ್ಯೇಯ ಉದ್ದೇಶಗಳು, ಆಬ್ಜೆಕ್ಟಿವ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಲ್ಲ, ಆ ಆಬ್ಜೆಕ್ಟಿವ್ಸ್ನ ನಾವು ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು, ಪರ್ಫೆಕ್ಟ್ ಇರಬೇಕು ಆ ಆಬ್ಜೆಕ್ಟಿವ್ಸಲ್ಲಿ. ಎರಡನೇ ರೀತಿಯಲ್ಲಿ ಅಂತಂದರೆ ನೌ ಡೇಸ್ ಇಟ್ ಈಸ್ ಆಲ್ ಡೇಟಾ ಡ್ರಿವನ್ ಅನಾಲಿಸಿಸ್ ಆಗಲೇಬೇಕು. ಏನೇ ಒಂದು ಫ್ಲೈಓವರ್ ಮಾಡ್ತೀನಿ, ಒಂದು ಅಂಡರ್ಪಾಸ್ ಮಾಡ್ತೀನಿ ಅಂತಂದಾಗ ವಿ ಶುಡ್ ಹ್ಯಾವ್ ಎ ಟ್ರಾಫಿಕ್ ಕೌಂಟು, ಟ್ರಾಫಿಕ್ ಫೋರ್ಕಾಸ್ಟು ಮತ್ತು ಟ್ರಾಫಿಕ್ ಪ್ರೊಜೆಕ್ಷನ್ಸು ಇವೆಲ್ಲನೂ ನಾವು ಪರ್ಫೆಕ್ಟಾಗಿ ಮಾಡಿದಾಗ ಅಲ್ಲಿ ಅಡ್ಮಿನಿಸ್ಟ್ರೇಟರ್ ಆದವರು ದೇ ವಿಲ್ ಬಿ ಏಬಲ್ ಟು ಟೇಕ್ ಡಿಸಿಷನ್. ಇಲ್ಲದಿದ್ದರೆ ಬಿಡಪ್ಪ ಇವ್ರು ಏನೋ ತೊಗೊಂಡು ಬರ್ತಾರೆ ಈ ಸಿವಿಲ್ ಇಂಜಿನಿಯರ್ಸ್ ಪ್ರಾಜೆಕ್ಟ್ಸ್ನ ಅಂತ ಹೇಳ್ತಾರೆ. ಆ ರೀತಿ ಆಗಬಾರ್ದು. ಈ ರೀತಿಯಲ್ಲಿ ನಾವು ಫಸ್ಟು ವಿ ಸ್ಟಾರ್ಟೆಡ್ ವೆರಿ ಸ್ಲೋ ಇನ್ 2023 ವಿತ್ ಎ ಕನ್ಸಲ್ಟೆಂಟ್ ಟು ಡೂ ಓನ್ಲಿ ಡೀಟೇಲ್ಡ್ ಫೀಸಿಬಿಲಿಟಿ ರಿಪೋರ್ಟ್ಸು. ಅವರಿಂದ ನಮಗೇನೇನು ಡೇಟಾ ಎಲ್ಲ ಬಂತು ಆ ಡೇಟಾನ ಅನಾಲಿಸಿಸ್ ಮಾಡಿ ಅದಕ್ಕೆ ಯಾವ ರೀತಿಯಲ್ಲಿ ಎಂಡ್ ಟು ಎಂಡ್ ಸೊಲ್ಯೂಷನ್ಸ್ನ ಯಾವ ರೀತಿಯಲ್ಲಿ ಮಾಡ್ಬೋದು ಅನ್ನೋ ಒಂದು ರೀತಿಯಲ್ಲಿ ವಿ ಹ್ಯಾವ್ ಡನ್ ದಟ್. ಸೊ ಈಗ ದ ಗೌರ್ಮೆಂಟ್ ಈಸ್ ಆಲ್ಸೋ ಕನ್ವಿನ್ಸ್ಡ್. ಸೊ ಏನು ಪ್ರಾಬ್ಲಮ್ ಇದೆ ಅಂತ ಹೇಳೋದಕ್ಕಿಂತನೂ ಪ್ರಾಬ್ಲಮ್ ಡೆಫಿನೇಷನ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಆ ರೀತಿಯಲ್ಲಿ ನಮ್ಮೆಲ್ಲ ನನ್ನ ಯಾರಾದರೂ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇರೋರಿಗೆ ಮತ್ತು ಎಲ್ಲ ವರ್ಕಿಂಗ್ ಸಿವಿಲ್ ಇಂಜಿನಿಯರ್ಸ್ಗೆ ನಾನು ಏನು ಹೇಳೋದು ಅಂತಂದರೆ, ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರಾಬ್ಲಮ್ ಸ್ಟೇಟ್ಮೆಂಟ್, ರಿಸಾಲ್ವ್ ಮಾಡೋದಕ್ಕೆ ಅಬ್ಜೆಕ್ಟಿವ್ಸ್ ಮತ್ತು ಡೇಟಾ ಡ್ರಿವನ್ ಅನಾಲಿಸಿಸಲ್ಲಿ ಮಾಡ್ತಾಯಿದ್ರೆ ಎಲ್ಲನೂ ಅದಕ್ಕೆ ಸೂಕ್ತವಾಗಿ ಅನುಮೋದನೆಗಳು ಅಪ್ರೂವಲ್ಸು ಸಿಗ್ತವೆ ಅಂತ ಹೇಳ್ತಾ, ಇನ್ನು ಮುಂದಿನ ದಿನಗಳಲ್ಲಿ ಡೆಫಿನೆಟ್ಲಿ ಬ್ಯಾಂಗ್ಳೂರ್ ಹ್ಯಾಸ್ ಟು ಚೇಂಜ್, ಬ್ಯಾಂಗ್ಳೂರ್ ವಿಲ್ ಚೇಂಜ್. ಹಾಗಾಗಿ ಆತನ ಹೇಳ್ತಾ ತಮ್ಮೆಲ್ಲ ಇವತ್ತು ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮ ಮಾಡಿದ್ದು ಭಾಳ ಸಂತೋಷ ಆಯಿತು. ಸೊ ಎಲ್ಲ ಬಂದ ತಕ್ಷಣ ಕೇಳ್ತಾಯಿದ್ರು ಆನ್ ಟೈಮ್ ಇದ್ದೀರಲ್ಲ ಹೇಗೆ ಅಂತ. ಇಟ್ ಈಸ್ ಬಿಕಾಸ್ ಆಫ್ ಜಸ್ಟೋ, ಇಟ್ ಈಸ್ ಬಿಕಾಸ್ ಆಫ್ ಇಂಡಿಯನ್ ಇನ್ಸ್ಟಿಟ್ಯೂಷನ್ ಆಫ್ ಇಂಜಿನಿಯರ್ಸ್ ಇಂಡಿಯಾ ಮತ್ತು ರಾಸ್ತಾ ಎಲ್ಲ ನಾನು ಕೊಟ್ಟಿದ್ದು. ಸೊ ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್. ಥ್ಯಾಂಕ್ ಯು.
ಧನ್ಯವಾದಗಳು ಸರ್. ಇಟ್ ವಾಸ್ ಅ ವಂಡರ್ಫುಲ್ ಇನ್ಸೈಟ್. ಐ ರಿಕ್ವೆಸ್ಟ್ Praveen to hand over the memento to Dr. B.S. Prahlad as a token of love, along with Veer Raghavan as well as Ratnakar Reddy. Thank you. Keynote address, no? First keynote address, ಅವ್ರನ್ನ ಬರಕ್ಕೆ ಹೇಳಬೇಕು.
I think before we invite Dr. Sridhar to talk about the today's discussion, endowment lecture, I want to say a few words. I think, sir, the object of this association is knowledge dissemination. And we have been associated with a number of government agencies in solving their problems. I personally feel that today's event should enable the association to participate in the problems that you face in solving the traffic problems as well as sustainability issues. We have here, I think myself and Guru Vittal are here. We have been associated with the Pradhan Mantri Gram Sadak Yojana ever since inception in December 25, 2000. For the last 25 years, even today, we have been associated with the program. The one program wherein the academia and the industry are very closely associated in taking up the rural road connectivity and the problems, new materials, new technologies. So what I request today to Mr. Patil and Dr. Prahlad is that we have a list of number of eminent highway engineers, experts, teachers, students, everybody is there. The object of this association is to groom employable engineers. So one of them which they all request is that, and we have eminent consultants also here. So it is a group of academicians as well as technocrats from the various industries, students, and many more experts are available here. So what I request at this forum is that, request both Mr. Patil and Mr. Dr. Prahlad is that, and Mr. Jayaprasad is also here, kindly associate the academic institutions in solving your problems in terms of good road construction practices, good maintenance practices, use of new materials, new technologies, solving the traffic problems. I think they will be very much interested, and that is what they need for the MTech project work. In this process, they will have a feel of the field problems, and in this way, we will be able to groom employable engineers in the country. They will get better employed by solving the day-to-day live problems. I request both Mr. Patil and Dr. Prahlad to get us to associate the academic institutions in Bangalore to solve not only the problems of Bangalore, but all over the Karnataka. So they will also get the satisfaction that they have taken up something for the state, and their research outcomes are being implemented. So they will feel proud that research has contributed to improve the quality of the life of the people of Karnataka. I think let the forum be a starting point for better academia, industry interaction in the years to come. We look forward to hear from you the field problem that you face. And every year, perhaps, you can give the list of problems. We will give it to the students. And at the end, we'll submit a report within 1 year or within 6 months. We'll give a report. And that is the way we should work together. I think let us all work together to improve the quality of the life of the people in Karnataka as well as in other parts of the country. Thank you.
Thank you, sir, for that wonderful way of telling that how we need to bridge the gap between the industry, academia, and as well as the practicing engineer. Thank you so much, which was always what we have been doing. Even as highway engineers also, we have been translating the same. So happy to hear once again. Now, without much wasting the time, and then now we will go with the keynote address on the premature failure in the flexible payments with emphasis on the top-down cracking by Dr. Sridhar Raju. I request all the dignitaries to be seated down. I am reading it. Dr. Sridhar Raju is a professor in the Department of Civil Engineering at BITS Pilani, Hyderabad campus. He has held additional roles as the Associate Dean of Academics for Undergraduate Studies and the head of the Department of Civil Engineering. Dr. Raju obtained his PhD from IIT Kharagpur in the year 2008. He had previously worked as scientist at Shell Global Bitumen and Asphalt R&D Center, Bangalore. He has also served as scientist at the Central Road Research Institute, New Delhi, between 1999 to 2005. Dr. Raju holds 2 patents, one on the utilization of waste plastics in bitumen and other on the bio-based encapsulation of bitumen pellets. He has led notable projects, including an ongoing study on top-down cracking in bituminous surface funded by the Ministry of Road Transport and Highways. Dr. Raju has co-authored key guidelines with the Indian Road Congress. With this brief introduction, I hand over the mic to Dr. Sridhar Raju for his keynote address on the premature failure in flexible payment with emphasis on top-down cracking.
Yeah, thank you, Uday. Yeah, good evening, everyone. I would like to thank the organization for giving me this opportunity, and Professor Veer Raghavan in particular. Yeah, before beginning, Jayaprasad sir, if education is a horse, experience is a jockey. You are an experienced person. I only speak what I have learned in these years. If you actually ask AI, it can give this in 8 minutes, but I have taken 8 years to understand this. Yeah. So this is Professor CEG.Justo Endowment Lecture 6 series. It is premature failure in flexible payments with emphasis on top-down cracking. Yeah, this was my PhD topic as well. When I heard this topic, top-down cracking, it went above my head. It went on top of my head. So I thought, why did I come to do PhD? I thought I knew something I will do on that, but it was completely a new topic. And to add on to that, my external examiner was Professor Veer Raghavan. So all my fellow PhD scholars were telling it is your professor, you don't have to worry, but only I knew what it is. The only thing happened was my kerchief was wet. I was sweating, but sir didn't leave me. And after that, he asked any other questions. Everybody were saying that this is more than sufficient. We cannot ask any questions. Yeah, maybe there are two reasons for that. One is he wanted to see that how a student has understood the topic and worked on it. The other one is to explain to other people that, yes, we train the students here at Bangalore University in such a way that they can handle any type of problems. Thank you, sir. So, a typical flexible payment, which we all know, but I will concentrate only on the top bituminous layer, which is more than 50% of the cost. And in that, it will only be the surface layer because the cracking is from the top, not from the bottom. Yeah, the word sustainability was spoken a lot, and it is quite commonly used these days. So I also put that design for sustainable payments. Why do we design the payments? It is to support the load, smooth riding quality, and good drainage. Yeah, only two critical strains we consider, and we have been considering all these days. One is the compressive strain on top of subgrade and the tensile strain at the bottom of bituminous layer. But there is something beyond this these days. We also need to consider the shear stress between the tire and the pavement. That is what I will stress upon and speak on those topics today. Yeah, we use the reliability equation. It is not the design reliability. It is only reliability to say how the subgrade behaves, and whatever rutting happens on the subgrade will get reflected on the top in this form. If I say it is rutting only because of subgrade, it may be true or it may not be. It could be because of the asphalt pavement itself. The rutting could be in the asphalt pavement itself. And then we actually find for fatigue failure. Earlier it was very critical because the asphalt layer thickness was quite less. So bituminous macadam in open graded mixture was used. So there is high possibility of cracking from the bottom. But in present day, with the use of dense mixes like DBM, high modulus asphalt layers, this is not very critical. Generally, we provide around 200 mm thick asphalt layer. It could be either at the bottom of the wheel or in between the dual wheel. So we have an equation here where we added a parameter called C. That C is having 10 to the power m. M is nothing but the VFB characteristics, voids filled by bitumen. If you know the voids filled by bitumen, we will be able to say what will be the fatigue life. But there is a lot of mistake happening because of this. We sit and design telling that the voids in the bitumen, or the effective volume of bitumen is 11.5%, air voids is 3%, but very, very challenging to achieve on the field. But when we design considering that 11.5 and 3% air voids, we get a C value in the range of 3. So our fatigue life improves by 3 times. So we reduce the thickness. Reducing thickness should not be the solution all the time. This is based on some of the observations what I have made. There was a site where within 3 years, the rutting had occurred. And the rutting is so severe that it had gone up to 40 mm rutting. And they have used highly modified bitumen, PG76E-10. But still the rutting had occurred. And then when they adopted this rich bottom bituminous layer, the thickness was 160 mm. But if you assume C as 1 and design the pavement, it is 250 mm what is required. Almost 100 mm saving, is it worth? And within 3 years it failed. It is supposed to last for 20 years. And using PG76, it is supposed to last for much more than 20 years. And then we see this cracking, which is fatigue cracking. Generally, we have a feeling that it is only from the bottom, but just by observation, we cannot say whether it is from the top or from the bottom. But our design is considering that it is cracking from the bottom. And then we design based on traffic. We always assume that VDF given in the IRC. But many a times that is wrong. I would like to quote one example here. We have to carry out the axle load survey. I would like to quote one example. The engineer-in-chief, the former engineer-in-chief of Telangana, he had a very different design of pavement. He used to do only 30 mm BC, and then he has paved many roads with the same budget, and it has worked in many places. So I was appreciating him for that, and we were having some discussion. He said that only one thing is bothering me. There is one road which has failed within 8 years. And that happened to be the former CM's constituency. It was in 2023. So he took me there, we went around. And then I said, sir, what was the design traffic? He said 10 MSA because this is a state highway, but not much traffic on this road. So it was designed for 10 MSA. Okay, fine. But within 8 years, there was rutting and some cracks and potholes also had occurred. When we were traveling to that road, I found that many trucks were passing by. I said, sir, if you give an opportunity, I would like to carry out the axle load survey at this location. This was the one. Yeah, he said, please go ahead. He also visited with me. His name is Shri Ravindra Rao Garu. With respect, I call him as Shri Ravindra Rao Garu. We went and did the axle load survey. The VDF was, on one side it was 17, the other side it was around 7 or so. On an average, we took it as 17. One side it was 22.5 because there was a quarry there. And the other side it was 12.56, which is 17.53. And the traffic was 1,200 trucks per day. I'm rounding off, I don't remember the exact number. And then it was designed for 10 MSA, but within 8 years, 26 MSA has passed on that road. No road can sustain like that. So I said it has exceeded the design life, sir, so it is high time that we do the overlay. Then we carried out some evaluation study and proposed a thicker layer, but he says, can we reduce it? So we made it 50 dBm plus 40 BC. That is the least we could do it. And now it is able to sustain. What was the reason for this? They estimated traffic. They also did some survey. Everything was perfect. But this became a crossroad for Nagpur to Warangal, Nagpur to Vijayawada. They don't have to pay the toll on the ring road. They don't have to pay the toll near Nagpur road, which is very near to Hyderabad. So they take this deviation, go to Warangal. It's a huge saving for the trucks. But how to think of all this? No designer can even estimate this. No engineer can estimate. But the blame goes to the engineer. As soon as we went there, they're telling the engineer em chestaro telidu, road potane untundi. But it has sustained for 8 years, which is almost equal to 30 years for normal traffic. But it is very difficult to convince each and everyone. Sometimes I had seen on an auto rickshaw, I am not deaf, I ignore. I think we have to follow that. I am not deaf, I ignore. But still we have to do what is required. So how is that we achieve this sustainable road? Design-wise, yes, we did that. How is that we can achieve it? There are various means of doing it. Now what we take is the shelter of the polymer modified bitumen, which is 1.6 times costlier than of a conventional bitumen. Or we can use the fine-grained crumb rubber with encapsulation. This was something which I did, and I have filed a patent on this. You can encapsulate crumb rubber so that You don't have to heat the bitumen. When you heat, there is settlement. In cold form, you can use it into the pug mill and then get the mix. I've tried it various mixes, various number of times it has worked, but I don't know how does it work in a big scale. That is what I'm waiting for. But in any other mixer, if you try to do it, a mini mixer in your own lab with 30 kg, it works. No need of heating the bitumen. Or these days we talk about high modulus asphalt, which is a DBM layer. So we get it from a batch mix plant. And then we get it onto the truck, take it to the field, roll it, finish. We feel that we have done all our duty. We also check the temperature. We will see how the mix temperature is when it is rolling. If it is too hot, we will allow it to cool down. If it is too cold, I don't know what to do there. And then we also check for density. All this is done. Or we can also use infrared camera. We used it in one of the projects. From the plant to the site, how the temperature varies. This was for a warm mix asphalt. It can be used for any other asphalt. You know how the temperature varies from the plant to the site on any particular day based on the temperature. So this gives an indication when did we finish our compaction. Like sir was mentioning, everything is data driven. Yes, it is a data. It is proven data. I can write the location. I can say what time, where, which date, what truck had come. So we followed all quality control. And while rolling, we said that let us follow 4 rules. What are those 4 rules? How many passes are required to finish the width? How many passes to achieve that required density? Whether the mix was hot or not, and what should be the speed of the roller. All these are followed because every engineer wants to do quality work. Let us not blame any of the engineers here. They all want to do quality work, but still we get failures which are premature. First thing, it goes with our perception. We have some experience, we go with the perception, not data driven. We see a rutting which is within the first 3 years or first 2 years. In fact, I had predicted this will rut, but in fact, it got rutted within 3 years. It is as high as 40 mm. So the next blame we say is maybe rich bottom bituminous layer. I cannot speak on this. As I told, if I give this question to AI, it will give me some answer. Maybe it is correct and maybe not be. But I don't have that authority to speak on this, but this is an open statement, and it is a topic for a thought, whether rich bottom is the one which leads to premature rutting. I don't know. It is still an open statement. It can go with perception, but not with data. The other one, what we see as premature failure is the top-down cracking, which can occur within 6 months to 3 years from the date of construction. But it is very difficult to say whether it is from the top or from the bottom. The only way is you have to cut the core. It becomes a destructive testing, but no other go. You cut the core, you get to know whether it is from the surface or from the bottom. So we always think that it could be because of the mixture design. The gradation was not followed. All these are perception. Or maybe moisture damage. Or maybe aggregate was not coated properly. Or the rolling pattern was not followed. I would like to give a different perspective. What could be the technical reasons? I'm not telling it what other perception is wrong. There is no wrong answer on this earth. The only thing what we look for is an appropriate answer. Yeah, if you write any of the competitive exams, 4 answers will look similar, of which 2 you can eradicate, but 2 looks very similar. But still we have to choose the most appropriate answer in a similar manner. What we have to see is the appropriate reason for this failure. Most of our layered elastic theory speaks of circular loading. But actually, the truck load is never circular. It's not elliptical as well. And then the treads plays a very, very important role. For the truck, it is very good. For the road, it is very bad. Because it induces highly tensile stresses or strains on the surface, which is quite high than the material can face. it leads to surface cracking. This is one of the technical reasons. And because of these treads, I use a 0.56 MPa tire pressure, but if I actually measure it is 0.76 MPa. But nobody will go with 0.56. I have seen trucks with 1.4 MPa. If that is 1.4 MPa, the actual on the pavement will be 1.8 megapascal. Also, we always think the truck to be static in nature. It is not. We design the pavement for a moving truck. When a truck is moving, it is rolling force, acceleration, and braking. If you see on any of the approach road towards a bridge on the embankment, we see a lot of rutting or surface cracking. It is because of change in the gear, there is an acceleration. So there is a traction force which comes horizontal along with the vertical load. That induces surface cracking. This is one of the road pavement where I was telling. It's on the approach road, on the downside of the approach road. Because they used PG76E-10, what you could see is there are some cracks which is not highly visible. But if they had used VG40, this would have resulted in top-down cracking. But because they used a highly modified binder, it has led to rutting. So what to do between the devil and the deep sea? Should I go with surface cracking or should I accept rutting? So this is one of the road pavements where I recently visited in Telangana. This is because the temperature was so high. I think it reaches 50 degrees air temperature. Imagine the pavement temperature. Even 76 does not work. And one more reason is we always think the temperature along the depth of the pavement is uniform. It is not. There is a gradient within the temperature from the surface to the depth. So I measured it in one of the national highway. That was during my PhD time. And even now it is valid. Because of this temperature gradient, there is also a stiffness gradient. Okay, how does it matter when there is a stiffness gradient? When the mix becomes very soft on the surface and there is a rolling force or a braking force, there is a traction force which creates a transverse crack which will not be healed because the top surface gets aged faster. The binder on the top surface ages much, much faster than what it ages at the bottom. So I did not speak about this, about bitumen. Short-term aging, yes, as soon as the mix is done, it is short-term aged. Long-term age happens over time, but if the air voids are more than 8%, the long-term aging within the top 20 mm is accelerated. This is not based on any literature alone, it is based on the observation on the field. We have studied this for 3 years on a monthly basis, because if you go after 6 months, something would have happened, we don't know when it happened. It is like observing a patient in the hospital every now and then. We observed it every 1 month, and thanks to Sri Ravindra Rao Garu, who asked us to take up this project on a monthly basis. Yeah, in a nutshell, I have tried to give this causes for top-down cracking. Most of the causes, what is perception, holds good here. Construction issue, traffic loading, pavement structure, bituminous mixture design. But the other 4 we did not consider, that is thermal effect, horizontal traction force, non-uniform contact stresses, and the stiffness gradient. We did not consider this. Very difficult to do this using the layered elastic theory, because the tire is not uniform along one side. You can't even do a 2D analysis. In USA, they can do 2D analysis because their treads are different from us. It's a steel radial tire. Ours is a nylon tire. What we use is a bias ply, a nylon at 45 degree, one over the other, which will have 12 plies. So it is a 3D finite element. This was the typical tires which are being used in India. So we try to find what will be the effect if you do a 3D finite element analysis. And we have to use some failure criteria. I cannot just like that define and say that yeah, there is high stresses and it fails. But there should be some limitation, some reference point to say, when does it fail? That's why in highway engineering or pavement engineering, we never consider stress for flexible pavement. We always consider strain, whereas for rigid pavement, we consider stress as the failure criteria. So I had to arrive at some point, so I used octahedral shear stress, which is almost similar to that of von Mises, but in a different style. So here, ITS is the failure criteria we used, but we can also use the present-day CT index test as the failure criteria, though these are crack propagation, not crack propagation, these are crack propagation, not crack initiation. These tests are only for crack propagation, not crack initiation. A 4-point bending test would be ideal for crack initiation, but it takes long time. So this is a very simple test. I use this and set 0.47 times of sigma y based on some of the literature. You can see there when the temperature goes high, the octahedral shear stress value literally comes down. And one thing you may ask, at 55 degrees, is it elastic? No, it is not. Viscosity plays a role, but on a road pavement, when there is confinement all around, we can still consider it to be elastic. That was the assumption I made and considered this to be elastic. Though it is not elastic, if you argue it is not elastic, I fully agree, it is viscous at 55 degrees centigrade. So when a tire is moving and there is a traction force, you can see that there is a stress in the front of the tire, and that is in transverse direction. In USA, what they get is longitudinal cracks. What we get is transverse cracks. But later on, it leads to map cracking, because once the initiation happens, it no more obeys the Hooke's law. It is no more elastic in nature. The continuum is lost. The cracking can be in any shape. So along the wheel path, what you see is a block type of cracking or a map type of cracking or an alligator cracking, not only one single longitudinal cracking for the tires what we have in India. And when there is a braking force, it is behind the tires, especially when there is a severe braking in the afternoon of a summer, you see a crescent moon failure on the road pavement, and that is because of the braking force. And one more thing is, the interface between DBM and BC will be smooth at that location, so that 40 mm or 50 mm just slides away, and what you get, a crescent moon failure. Yeah, I try to put that in the form of octahedral shear stress ratio. That is, whatever the stress I get, the maximum stress divided by the octahedral shear stress value. You can see everywhere it is red. Means every movement is critical. It can initiate top-down cracking. If there is no healing effect, if the bitumen does not heal on its own, it is completely edged, it will definitely crack. But if there is healing effect, the cracking will delay. It will take more time to crack than expected. This is how a linear elastic theory gives. At the center of the wheel load, we say there is not much of a stress, but at the bottom, the stress or the strain is quite high. So that is a bottom-up cracking. That is correct. But when we consider a tire as non-uniform contact stress, and because of the rolling forces, the stress on the surface is much higher than that of the bottom. What we use is this type in most of our analysis, but what actually happens is this one. So every pavement is bound to have surface cracking. I am not wrong. You can visit any site on the present day scenario. Within 4 or 5 years, whatever cracks we are seeing, it is not bottom-up cracking, it is top-down cracking. Yeah, if the loading is increasing, this becomes even more further severe. And I mentioned about smooth interface condition. When there is no bonding between DBM and BC, what will happen? The stress between the layer is much higher. So if there is a crack initiation, it follows to full depth within no time. And that is for a standard load I have shown. If I want to express for a heavy load, even there it is critical. The surface cracks first, and it goes to full depth of BC layer, not full depth DBM I'm not talking about, up to BC layer. I will show a picture. Seeing is believing. I will show you a picture. This BC layer had cracked. This is one of the site location. There was no bonding between DBM and BC. Within no time, it is accelerated. Initiation is difficult once it initiates, and if there is smooth interface, it is accelerated. Within 6 months, it comes into 2 parts. So how to understand this? All this finite element analysis is all something as a black box. It does something inside. We don't know what is happening. How to do this one? Yeah, I am proud to say that I am also from Prof. Justo School of Thought, where we try to fabricate the equipment, not buy the equipment. There was one De Beer in South Africa who purchased an equipment and did the studies. The cost of the equipment on those days, 2005, it was 1 crore. We did it in 10,000 maybe. And then we tried to simulate the truck having a vertical load and then traction force. Our results were comparable to with De Beer. It's not that it is completely same as that, but it was comparable. That was sufficient to say what we are doing is on the right path. We are not away from what others are doing in the developed countries or developing countries. So I modified further when I got a project from NHI. Thanks to NHI, they trusted on me and gave a project. I further tried to enlarge it to 1 meter by 1 meter box and put the complete pavement, and then tried to study for different layers, maybe BC with modified binders, and then also with stone matrix asphalt and gap graded rubber asphalt, which Professor Pandey was promoting a lot. And also try to use some lighting arrangements so that it heats the surface, and try to age to a certain extent. And use the shunt resistor to measure the strains at the bottom and on the surface. Yeah, it was validated with respect to theoretical value, but I tried to measure using the recoverable strain. When we apply a strain, the surface gives some strain, but it also recovers back. If you use a PMB, the recovery was much higher than when using a VG30 or a VG40 bitumen. So from this, we can infer at least that on the surface, when the traffic is heavy, I think we have to use a PMB. That's one of the reasons that we have to go for PMB. I was still not happy with that box setup because it has constraint. It has 1 meter by 1 meter. I can't pull and push like what is happening in the real field. So I tried to build a semi-field test track within the campus of BITS Pilani. And we used the roller and so on. And thanks to R&B department, Telangana State, who helped us with all this. Again, sir, we followed the same Professor Justo's thought that we collaborated with R&B department. That's how we were able to do some good projects. The recovery of SMA was as high as 83%, even when the load was 12 kilonewton. But it was only 50% when we use VG30. And there is no aging. It is still fresh bitumen. Still the recovery was low. So all these are laboratory studies. If I go and tell any engineer, please give me a project I have already proven, they will say, lab is not sufficient to fund you the project. And if I say we will do a trial section, so far I have not seen any trial section fail. Trial section is like, it never fails. If you go to any petrol station, they will give one liquid and he will wipe our car, and then the scratch mark goes away. And we get impressed and he gives us one water bottle. We say, no, whatever you have, you give that bottle. I will give you 5,000 rupees. He won't give. He'll give only that bottle. So like that, most of the time, trial sections we do with lot of precaution and it works. So what I requested the ENC was that give a section which is already constructed. We will study for 3 years. So then we can say what is the lacuna or improvement required. I'll not say lacuna. A positive note would be, how is that you can improve upon so that your payments will last longer. His view was it should last for 10 years. But we were able to achieve up to 7 years. I should feel proud about that. We were able to achieve 7 years, not within 3 years, it didn't fail. So we took 2 sections. Both are state highway, but different conditions. One was very near to our institute only, and it is a Karimnagar highway which goes to Mancherial a mining area. And the other one is the new holy place, which is Yadadri, that Narasimha Swami temple. So these two were the one which was given to us. We studied this every month after month. What was the study? It was a destructive study. We used to bring the course and extract the bitumen and say how much of bitumen has aged over time. But to our surprise, both did not have the same surface air voids or the same air voids in the surface layer. The air voids was different. When we cut the course and bring it, we found that the air voids was quite high for road number 2, and it was in the range of 7 to 8% for road number 1. And the traffic was less in road number 1, traffic was more in road number 2. Within 3 years, we could see some cracking on the surface. However, our predictions were 4 years. So 75% achievement or we failed. I just mentioned that in principle, in our predictions, we failed because we only studied the bitumen property. Along with the bitumen, how does the mix behave is what we need to see. And how was the trucks loaded? We don't know about that. So there could be a reason that it failed in 3 years, though our predictions were 4 years. But however, after 4th year only, they had to do some patchwork. You can see that it was 7.5% to 8% air voids in road number 1, but it was 7.1 to 9.1% in road number 2. From then on, they made it a point that the air void is below 8%. But we propose that it should be around 6%, which they are still trying to achieve. It is not very easy. But I want to make one thing here. Rich bottom bituminous layer, some of the contractors claim that they achieved 3.5% air voids in the field, which is next to impossible. The only thing they do is they reduce the GMM value so that they show 3.5%. In principle, it is not. I tried to plot these air voids with respect to time. If you see the mix with 8.5%, 9% air voids, there is sudden reduction because of heavy traffic. The other one was linear. But that initial itself is sufficient to do the damage. Whatever the damage required for surface cracking, that was sufficient. Because the bitumen had aged so much, the stiffness was so high initially, later on it was 2 parallel lines. There was no change in the slope. The first slope is only during the first 6 months. And that was sufficient to initiate cracking. So is the stiffness. Initially it was high for one road, low for the other, but others, it followed the trend. So the prediction was 4 years and 5 years. What was the prediction based on? We do something pressure aging vessel test where you heat and age the bitumen, which is simulating 7 to 8 years in the actual field condition. But we were not able to reach that in 7, 8 years, but because of higher air voids, it was reached within 4 years, and the other one 5 years. Now it is completed 5 years, it is not correct. The only reason is mostly it is car traffic, not the truck traffic as estimated. The other aging index also was measured. Even there it said that it can last for 4 years, but it started cracking from 3 years only. I was mentioning about this CT index, cracking tolerance index. It's a very simple test, and it gives an indication whether the material will be able to sustain or not. For road 2, it was 40.2. It is just a value. It is a relative value. If I do with a PMB, it will give around 65 to 70. That shows that, yeah, this mix can sustain more loading without cracking, without initiating the surface cracks. But in this condition, it showed that, yeah, the road number 2 cracked faster. How to understand this? The aging has occurred only in the top layer. We slice this into 2 parts. And if I do softening point, it is still not a better indicator. So what we did was a DSR study with this, which is generally used for a polymer modified bitumen, to find the recovery of the bitumen. The recovery could be because of polymer or rubber, But in this case, the recovery was only because of the stiffness of the binder. If I try to give a torque to a steel, it will not rotate, but still something has happened and it will come back to original. But if I rotate a rubber, it completely rotates and comes back. That is elastic, the other one is only stiffer. Here what we did was a stiff binder. It showed that 0.49. But on road 1, it shows us 3.25. It is still soft at the bottom, but at the surface, it is 0.49. So the surface is the one which cracks. That is why most of the researchers told that it is the top 20 mm which is critical for top-down cracking. The first top-down cracking, what we saw was on Bangalore-Hosur Road, the first project of L&T. And Professor Veeraraghavan had sent us to that location. We went, saw there. With our own knowledge, we said that you can do resurfacing, you can do fog sealing, whatever we learned, we were trying to say. But if I turn back and understand, that was top-down cracking. The first project of L&T, Bangalore-Hosur Road, it was top-down cracking. I want to mention about one thing here. Whenever there is a paving operation, most of us who go for inspection, we go and stand behind the paver. We make it like Bharat in Hindi. And roller is Anath. Nobody even bothers to go there. And that fellow will start rolling the time he wants. Most of the roller operators were actually pouring water to the roller and then upgradation, promotion, and they became. He says, Mundu ayana atle chestunnadu, nenu itle chestanu. So they never listen to us. But once our presence is there, it can still make a difference. So this is one of the scenario in a paving site in India. Nobody bothered about the roller, but everybody were behind the paver. Even when engineers goes for inspection, all of us will go behind them and stand on the paver. That is a machine, it can do any work. But roller is manual, so we have to be there. I would like to show one more example. This was in another country. We always compete with them, that is China. Nobody behind the paver, but whoever officers came, they only went to the rollers, they saw how the rolling operation is, and then went off. They did not say anything, they just observed the roller operation and went. And you can see the smoke from the roller. When the roller is moving, there was a huge smoke. They achieved density. Once the density is achieved, there is no question of failure. All this top-down cracking, I said, in the field was only with respect to air voids. Higher air voids, higher aging, and then top-down cracking. If the air voids is lower, if you bring it down to 6% of GMM, then there is no premature failure. With this, I would like to end my lecture, but I would like to share few memorable pictures with our beloved professor. Most of us we meet many people and they are in our memory. But very few people will be a part of our life. Professor Justo is one person who will be a part of my life. So I would like to share a few pictures which is there always with me. Wherever there was a interaction or attending some conferences with Professor Justo, I have never missed it. Yeah. And I would like to end my lecture with one statement. This statement I heard in 1996, the first lecture where Professor Justo took to us. This Uday was mentioning, it was told by Shri Abdul Kalamji, Dr. Abdul Kalamji. I don't know about that, but what I heard it from Professor Justo, teachers are like a ladder. They help to climb and reach heights, yet they remain steadfast in their position, providing guidance. If I want to see the meaning of simplicity, if I just look at Professor Justo, I think I'll get the meaning. I don't have to see any dictionary. Thank you very much for your patience hearing, and thank you.
Thank you, Professor Sridhar Raju, for this wonderful technical insight about the sustainable payment. Thank you so much. I request Professor Veeraraghavan sir to give a small memento as a token of love and appreciation to Professor Sridhar Raju. Sir. There is a small changeover. Now we'll just move on to the panel discussion, which is the next thing what we had planned across. Yeah. So we request the panelists to come onto the stage. To start with, we have Shri M.N. Anuchit sir, IPS, Joint Commissioner of Police, Bangalore Traffic Police. I request you to come on stage, sir. Welcome, sir. Shri M.N. Anuchit is a 2009 batch Indian Police Service officer, born to Karnataka, Kerala. He is currently working as Joint Commissioner of Police, Traffic, Bangalore City. He has a degree in B. Electronics from Avi College of Engineering and a master's degree in Police Management from Osmania University. He has served in various capacities of the police department across Karnataka, such as Superintendent of Police of Kodagu and Chitradurga districts, and as a Deputy Commissioner of Police of West Division, Whitefield Division, and Central Divisions in Bangalore City. He has been a decorated officer with awards and medals, awarded the Chief Minister's Medal in 2017, awarded the Union Home Minister's Medal for Excellence in Investigation in 2019, awarded the Nadaprabhu Kempegowda Award in 2020. Amongst his professional interest, he has been an integral part of several special investigation teams that were formed to detect and investigate sensational criminal cases. He has a domain expertise in investigation of new age crimes involving darknets, social media, and cryptocurrencies. He has been a keen advocate of use of the latest technology in traffic policing. So I welcome you, sir, for the panel. I request Professor Veeraraghavan, sir, to hand over a small bouquet. Thank you, sir. Now I request Dr. B.S. Prahalad, sir, the Engineering Chief, BBMP, and then we have already introduced him, and then we welcome him to the panel to share his vast experience amongst the August gathering. Now we have another panelist, Shri Venkat Subbarao Chundru, sir, Director, Arcadis IBA Group. I welcome you, sir. Shri Venkat Subbarao Chundru is a seasoned practitioner in traffic and transportation engineering with over 25 years of experience spanning the entire life cycle of transportation infrastructure project, including highways, metro rail, urban roads, airports, and ports. As a director and head of operations in Arcadis India IBI Group, he leads a team of 150 plus professionals driving technology integration, domain expertise, and strategic collaborations to enhance operational efficiency, safety, and sustainable in mobility solutions. His expertise lies in leveraging AI-driven traffic management, mobility digital twins, CV2X, cellular vehicle to everything, and intelligent transport solutions to build future-ready cities and highways. Over his career, he has led leadership roles at Infraweight Consulting, GMR Group, Wilbur Smith Associates, and Tata Consultancy Services, playing a pivotal role in planning, implementation, and operation and maintenance of landmark infrastructure projects such as Bandra-Worli Sea Link, Mumbai Metro, and over 500 plus kilometers of national and state highways, Hyderabad, Delhi, and Goa airports, JNPT ports, etc. He has successfully implemented adaptive traffic system, digital tolling solutions, and multimodal urban transport strategies, enabling smarter and more efficient transportation networks. A certified independent director from the Institute of Corporate Affairs, India, he has led the business transformation initiatives, driving revenue growth, digital adoption, and stakeholder engagement, achieving 20% sales and 30% improvement in digital adoption. Actively engaged in policy advocacy and industry leadership, he serves on the key and committees of the Indian Road Congress, Institute of Transportation Engineers USA, and Confederation of Indian Industry, contributing for the advancement in transport planning, multimodal integration, and emerging mobility solutions. Committed to harnessing technology, automation, and data-driven mobility strategies, he continues to make impactful contribution in shaping the future of sustainable transportation infrastructure, reinforcing Arcadis India's leadership in smart mobility and infrastructure innovations. We warmly welcome you, sir, to the desk. Now, we also have Dr. A. Veeraraghavan, fondly called as AV sir, as one of the panelists. We welcome you, sir, to the panel. And we also invite Shri Ratnakar Reddy to be the Managing Director of Infra Support Engineering Consultants, and also the Secretary of OBE to be one of the panelists. Now I request AV sir to kickstart the panel discussions on Indian urban roads, mobility and sustainability. Thank you, sir.
Thank you, Lokesh. We'll do that later. Please. Yeah, we'll definitely we take your views. Yeah, we do agree. We fully respect you. We'll talk with the as we go. We'll definitely have this. No, please, 100%, 200%, 300%. So, because of time limitations, I think we had taken up the panel discussion on urban mobility and sustainability. We have an eminent panel with us. I think as every one of you are aware, the urban mobility and sustainability are related to how people and goods move around the cities and how this affects the environment, economy, and society. The talk of the day today, I think when Mr. Patil talked and Dr. Prahlad spoke also about the traffic problems of Bangalore and how to solve it. I think Bangalore is an example about solving the traffic problems and how the initiatives taken up by the government. I think Mr. Anchut has taken many initiatives. Venkat also is, I believe, supporting him along with Ratnakar Reddy. I think in this panel discussion, let us hear from them, their initiatives, their action plan, how to move people as well as goods safely, efficiently, economically in Bangalore, and what are the initiatives of the government and how, with the way forward. So I don't want to take much of your time. I request Mr. Anchut to talk about his views, thoughts, experiences in solving the traffic problems of Bangalore. Over to you, Mr. Anchut.
Good evening, everyone. Thank you for inviting me to speak today on various issues regarding urban mobility. Insofar as Bangalore Traffic Police is concerned, what we have been trying to do is that given our existing sphere of influence and our roles and responsibilities, we have tried to give focus to traffic management and traffic regulation. Some of the initiatives we have taken is, one is the introduction of adaptive signals in various junctions of Bangalore city. It has been fairly successful, and we are trying to improve that as well. The hope is that with adaptive signaling, the vehicular throughput would improve at the junction, and therefore the overall speed and reduction in timing would occur, which has happened in most of the junctions. And from a traffic police perspective, in about 100 junctions, we have completely removed staff, which previously would take 2 or 3 staff at, particularly during peak hours, we have been able to remove. And manual operations has come down from 40% to about 5 to 6% now in a majority of these junctions. Secondly, the use of big data and AI in terms of a macro level platform called Astram, we have been able to get some useful insights regarding how traffic flows in Bangalore. And through these insights, we are able to take data-driven decisions and give our response in a structured way, as opposed to previously what used to happen in what used to have like a gut feeling kind of thing. We are able to gather large amounts of data as well. We are using that data to analyze and create furthermore new technological interventions by way of digital twin, agentic AI, and other things. So that is in terms of technological perspective. The other things that we have tried to do is that we are trying to work within the existing infrastructure to improve pedestrian safety. BBMP has started the Suraksha 75. They have also taken up some road infrastructure measures in a very large way in certain tracts of Bangalore city. So we are trying to work with them. Bangalore is a developing city. As you all know, lot of infrastructure works are happening, which right now are impeding the flow of traffic, especially on ORR and other things. But the hope is that once they are ready, the public transport infrastructure would improve and the dependence on private transport would reduce. That I feel is the long-term solution to Bangalore city. And apart from these, the physical measures have been taken in large tracts of Bangalore city, but 2 issues still remain. One issue is the lack of parking spaces in Bangalore city. I think Bangalore is not a planned city. So what was residential yesterday became commercial today and probably became a tech park the next day, as it has happened in Kormangla and HSR layout. So what was meant for 1 or 2 cars today has a building which caters to 1,000 people, right? So I think this lack of parking spaces is one issue. So parking on the road actually reduces the road efficiency by about 30%. Our simulation predicts that anywhere between 30 to 33% of throughput would increase if we completely remove all kinds of encroachments and road parking. But it is easier said than done. The other issue that we are seeing which affects traffic movement is the growth of vehicles is not met with commensurate growth in infrastructure. It will never meet because infrastructure always takes times to meet the need of the day. So I think instead of our thinking should change from moving a vehicle from point A to point B to moving a person from point A to point B. What I call moving from traffic towards mobility. I think that is the only way we'll be able to solve the problem in Bangalore. Otherwise, in the long run, it is going to be very difficult. See, from 2013 to 2023, we exactly doubled our vehicle population. It was 56 lakhs in 2013. It is 1.12 crores in 2023. It is 1.23 crores as on February 28, 2025. Now in 2033, if it doubles, we are going to have 2.24 crores vehicles. I don't know where we'll be able to move such a large number of vehicles in city. So I think the only answer to that would be shifting towards public transport for day-to-day work, like commute to office, that is during morning peak hours and evening peak hours, and the commute to school. If you can shift towards public transport. Many schools have already shifted by way of buses, but that conundrum still exists. I don't know how we'll be able to solve that. But rapid infrastructure is what is the need of the day.
Thank you very much for your enlightening talk, that it's time that we move people rather than moving vehicles. I think any city can be planned for a known vehicles, known population, but not for indefinite population of people as well as the vehicles. I think as rightly mentioned, the population of vehicles will go to 2 crores. How are we going to manage? It's a real challenge. I am sure that you will have many more questions to ask at the end of the panel discussion. So we want to cut short the panel discussion to enable you to interact more. I think we have with us Mr. Venkat Subbarao, who has already implemented many simulation studies. He has been associated with many interaction with the students in colleges. I request Mr. Venkat to share his thoughts on solving the traffic problems of Bangalore and the way forward.
Thank you, sir. I think amongst the eminent people and more experienced, I feel like my experience is nothing in front of you, sir. But with whatever little work that we've actually done in this sector, what we realize is where things go wrong and where things happen. I was able to clearly distinguish when we worked in multiple projects. So one of the important things that is actually happening in Bangalore, what I see is the technology is put to right use, but it's not just the technology, but it's also the domain expertise or the traffic engineering that is actually coming up, plus the collaboration that is also working together. So I think we feel the mix of these three is helping us solve the problems better, and that's very important aspect of the thing that need to be taken forward. The other important thing is that over-reliance on technology is not good. We also need to go with what is practical and what is realistic for us to do, because in some of the projects what we see, especially in the smart city projects, people think that by putting up a command control center or by installing a camera, people would have achieved their goal, right? So what is important is to actually focus on the outcomes than actually the infrastructure itself. So if all the key stakeholders are actually aligned to achieving a particular outcome, we actually see the magic happens. So the second important lesson that I learned is to actually keep the focus on the outcomes and then be agile and be open to actually changing our approach rather than very staying rigid with our way of thinking. See, as the problem or the solution progresses, we need to make sure, we need to tweak it around to make sure that we achieve the end outcome. The third important thing that I actually learned is what is also important in the whole scheme of collaborations, which is today not happening, and it's very important for the theme that we talked about to sustain these things forward. I'm actually seeing one of the disturbing trends is not many of the students who are actually studying traffic engineering are not willing to take up careers in traffic engineering. So we need to make this profession more exciting and more tech oriented, and that's one of the reasons why we are also trying to go to and collaborate with a lot of these colleges and then talk to more and more universities and to engage them on the projects. We take a lot of these interns on these projects. They come with fresh minds, fresh ideas, but also it also motivates them to actually be staying together, staying and sticking to the profession. It's very important that we attract and we nurture that particular talent. So that's one of the important things for us to have more and more people joining the bandwagon to solve these traffic problems, for it to be sustained, these solutions to sustain for a longer period of time. I think with that, thank you very much for this opportunity, sir.
Thank you. Anything you want to say? Sir, you want to tell anything? Yeah.
In my view, traffic has two legs. That is, the one is the road, and the second one is the road user. So what we need to do is we need to construct good roads, good network of roads. We have to put the infrastructure in place, then allow the road user to use it. So for that, what is very important, what we are doing in Bangalore is, we have started one concept called the Namma Raste program. Under this Namma Raste program, we are looking at the roads on the assembly constituency wise, which roads can be used for better movement of traffic, where the main roads are there, where traffic oriented developments can be made in the future, and how the traffic can be moved from one place to another. So it is like less traffic and more human life. So we have put a data-driven analysis. We are first studying how the pattern of the roads are. Many were complaining that the Mahadevpura is always congested and compared to the core cities and other places. When we did the analysis, the road network in Mahadevpura was 8 kilometers per square kilometer. Whereas in Vijayanagar or Jayanagar, if we take, it was around 24 kilometers per square kilometers. So when the road network is shortened, then definitely there will be congestions. So these analyses have been made. Wherever flyovers are to be made, where their end-to-end solution can be brought out by infrastructure, we need to put that in place. For that, as Venkat Subbarao told, we need to do an analysis using AI technologies and also map the arterial, subarterial roads, and also have a origin and destination survey counts. Today, taking a traffic count is not a big thing. First, we need to take it physically, counting the vehicles. But today, with AI technologies, with cameras, we can just run the camera and get the analysis of that. However, as our Joint Commissioner of Police Traffic was telling, there is a huge exponential growth of vehicles where we are unable to manage. Today's solution becomes nowhere in the coming days. So we need to have a neat road and road user combination solutions. That is my view.
Thank you, sir.
Now, traffic is always, it's a man-made problem. And when you talk about our own Bangalore, the biggest problematic areas is all we have only created. You take, Goruguntepalya, Silk Board, Kyarpuram, Ebbal, it's all our own problem. So the problem is we create a big, problem and then we try, finding a solution. Now, what we have been doing, as a consultant and as an engineer is that we are bringing, more data, more technology so that, we don't create, bigger blunders. So, we all know, we're all here, transportation engineers, there is a capacity of each road. We know V by C ratios, we know intersection capacities. If an intersection reaches a particular volume of traffic, and it takes its own time, there is a delay happens. Now, if somebody says that, no, this delay cannot happen at this junction, it's impossible. But what we can do is, we can bring a certainty to how much time it takes to cross the junction. We cannot, say, it can become a, green corridor. I think this is another, kind of either education or awareness we should bring to our own politicians also. The moment there is a traffic jam happens, the kind of, phones will go, the kind of pressure comes on the traffic police also. I really wonder what a traffic police on the road can really do in solving the traffic jam, unless we create some good infrastructure, we bring more technology on it. So having said that, the technology, the engineering, traffic engineering can save about 20-30% of the, efficiency, improving efficiency in traffic operations. So in BTP, under Sri Anuchal sir's leadership, we have now created a simulation model for the entire Bangalore city. The first of its kind. We have been talking for last 10 years. It never happened, but it happened. Now, with the simulation model, we can do a lot of analysis whether we can do a road one way, two way, if something stops, what happens, if you build an elevated corridor, what happens, if we close some entire road, what happens. So everything is available. So it brings a lot of certainty in decisions that we can take. So other important thing is, like, we talk on sustainability, like we spoke about pavement sustainability. You build a pavement, it should last long for so many years. The traffic engineering also, if you do sudden, intervention, it has to last long. We cannot keep changing, okay, I do today something and tomorrow I'll do something else. So now with the data and the technology, we can do a lot of sustainable solutions on the traffic. So, like having Anchal sir said, the shifting of, to public transportation. I mean, nowhere in the world a city can be robust in transportation without at least having 70 to 80% of the modal trips in public transportation. We are just at 20-25%. Unless we reach 80% of our own modal split to public transportation, we will continue to having these problems. We might build small solutions, maybe small interventions, but that will not solve our problem. And also one of the now that BBMP started now also talking about big data, like he mentioned, the Namma Raste was a wonderful event where all the data came. Now suddenly you can start looking at what's happening at Bangalore city. What is the statistics? So we all realize that now if we making wider roads is not going to solve the traffic problem or efficiency. So you make uniform lanes, it brings more efficiency. So now every roads in BBMP now, it has become a mandate that you make uniform lanes, whether it is 2 lanes or even 3 lanes, not that everywhere you keep widening. So there's another takeaway what BBMP started doing for a few years. Yes, bringing data and technology can improve traffic operations is the point, sir.
Thank you very much. I think we had eminent panelists shared their thoughts and views on sustainability and mobility in urban areas. I'm sure that the object of this panel discussion is to create new ideas, new thoughts, and the way forward. I feel that it is an opportunity for you to interact with the eminent panelists, the way forward. We also wish a better academia-industry collaboration in the process. I'm sure that when you talk about sustainability, there's a need for use of new materials, new technologies. An urban pavement management system has to be in place. I'm sure many of the students will be interested, who are interested in pavement engineering, to work on urban pavement management system. We have had eminent scholars who have graduated with a PhD in pavement management system. They will be able to guide. I think Mr. Prahlad, Dr. Prahlad will enable them to interact with the corporation, roads, so that we will be able to see better quality roads in the years to come. When you talk about traffic, again, there are many, many issues. Other point that have not been addressed is about the urban freight, urban road safety. I think we also talk about, we have to fail to consider the importance of pedestrians in safety. Pedestrian is also an element in the road design. Unfortunately, we don't consider them. We don't consider the safety aspects. There are many, many suggested remedial measures are possible, mitigation measures. Whatever done, are they effective or not? So effectiveness of the countermeasure is something that we have to do. Even starting from road markings, the quality of the road markings, the thickness of the road markings, the retroreflectivity of road markings, the effectiveness of road markings in enhancing safety, many more things can be studied. I'm sure that this forum will enable the students to interact with the panelists. So now at this point of time, I request the audience to pose their questions, students and teachers, to pose their questions and see as how you can get involved in sustainability and traffic management of Bangalore city in urban areas. It's open to you to ask questions on your thoughts.
Yeah. Good evening, I am Dr. Sukumaran. Everything very wonderfully conducted, the program, and the inputs are very interesting to all. One aspect is ignored is the human behavior. Road users' behavior is not touched upon. The road safety is compromised because of the erratic riding of the two-wheelers most of the accidents are happening due to the two-wheelers. Unruly they drive the vehicles. They don't bother about the road users to cross. They will speed up at that juncture. So this all gives room for compromising the road safety in spite of technological advancement, the academician and the R&D is bringing out to the society. That also should be considered as a very important parameter in safety analysis. And very appropriate, stringent regulatory control measures should be emphasized to ensure the safety of the road users. Thank you.
A very good evening to everyone. I am Dr. Gunashekar. I was one of those blessed students of Professor Justo, and I worked with him for quite a decade. Listening to the panel, I have heard so many panels speak in my probably 30, 35 years of experience. Sorry to say that I haven't heard anything new. Traffic is increasing at the same rate, doubling in a decade. We have parking problems. We have the same issues. One thing I think we are missing as technocrats is, we have a scale of problem on our left hand. The scale of the solution on my right hand must also be matching with that. But we aren't looking at the scale of the solution. For example, recently, the idea of tunnel roads was speculated, rather. You know, it became a political issue. But I think it's a really awesome idea. Somewhere we have to look at it. Singapore today is successful in spite of being a small city, handling so much of traffic because of tunnel roads. They have got tunnel roads. See, what we have as we have our metro rail, which should have come 20 years ago. Now we are still on it. I think these bold solutions, which is in the future, must come to now. And we have to look at policy decisions, planning in that direction. We have to tell our administrators, we have to tell our politicians, we have to tell the entire nation that until we have a scale of solution, we cannot solve the scale of this problem. Like the way we handled COVID, it was on a large scale. We had a large scale solution. And that's how India managed it. And I think we have the technical expertise and we have the intelligence to look at large scale solutions. Do away with management. It is like managing fever. I take 2 or 3 crossing and the fever comes down, but I don't lose the disease. But to get rid of the disease, there has to be a long-term thinking. And we are looking for a large-scale solution, sir. Thank you very much.
May I talk?
Yeah. Tell.
I am Dr. Raj Shankar from Dayanand Sagar, retired. Now I have some points to clarify from concern. This is with regards to signal designs. All signals need thorough evaluation regarding its level of service or delay during 15 hours of signal operation. Signals work, no doubt, but how much delay is occurring, what is the level of service provided during signal operation 15 hours now, that is more important in defining it. Second is, minor roads are given more time, which is not required. Because 10 years back itself, one of my students did a project, 50% extra time wasted on the ring road, PS College Road. So the provided time was 40 seconds, actual record is 20-25 seconds. For every cycle it's happening. And there are about 500 cycles in a day, almost. And then split green time on majority of roads is unsuitable. It results in rear-end collisions. And the queue length will spill out to the next junction. It's happening in Vijayanagar, very near to my residence. So split green, I think you understand what is split green time. So partly the vehicles go in both the direction and partly it is right and allowed on PS College Road. So this is very dangerous and the rear-end collisions will be very high. Then signal length, signal cycle time should be based on queue length formation, development and dissipation. That means you have to study how queue is formed on a particular road, taking all the factors into account. Then what is the time required for dissipation? So this will optimize in the sense the delay will be minimum and allow free left turn wherever it is possible. This is not permitted in many of the roads where it is possible. Example, Sangoli Line railway station, free left you can 24 hours allow with some amber indication. And unless it is prevented, vehicles taking turn. And even from Rajnagar towards Anura Circle, this is prevented. So this results in what? But the road is very congested now because after all modification that over. And then, example in KR Circle also, you can allow free left turn towards Vijan Soda from Maharani College. Similarly,
Dr. Rashekar, I think instead of suggestions, you can send all your suggestions to Mr. Anichus directly. Because of time limitations, I have to cut short the discussions. If there are any questions that you want to ask,
these are all my observations.
Your observations, you can kindly send it to him. He will consider that.
Sir.
Yeah. Because of time limitation, I am not able to allow suggestions to be posted at this point of time. If anyone got any specific, quick suggestions, questions, you can ask. Maybe a 1-minute question.
Yeah, thank you, the panelist. So one thing what I found missing is this no discussion on this land use transition and land use control. So which is actually very much important. We heard about moving people from moving vehicle to moving people, traffic to mobility, but we didn't touch what is the land use transition is happening and how to control the land use control. This is the mother of all problem, I believe. Okay, at the end of my things, let me introduce. I am Dr. Bhaskar from Datacop Traffic Private Limited. And I personally did my PhD in traffic signaling thing and happy to collaborate any of you for solving the problem of Bangalore. Thank you.
Sure, thank you, thank you. I think I request the panelists to respond to the comments, if any, and then we can conclude. The session is already past. Madam, end afterwards. Yeah. No suggestions, questions, sir. Yeah. Yeah.
On main roads.
That he'll respond.
No.
Yeah.
Why I am asking you, because if petrol bunk permissions are given on the main road where the heavy traffic is there, and there won't be any parking also, and one side that for the
Sakama, that's exactly what he told.
That is what I want.
Mr. Anichut has already mentioned that Bangalore city is not a planned city. It has grown from old city to today. So you cannot question what has been happened in the last 100 years. So that cannot be told.
Very recently.
Yeah, correct. That's why he'll answer. He'll respond to your comments.
Sheshadripuram first main road.
Yeah, fine. Okay. I think
for no commercial activity, traffic police permission is required as of today. Yeah. And I hope petrol bunk comes under commercial activity. So no permission is required as of now. Neither is a NOC asked nor permission given from traffic police.
Yeah. Venkat, you want to say anything? Yeah.
Sir, on two things I just wanted to answer. One on the kind of tunneling and other projects that you actually said. I think the challenge is about the decisions being taken without the data being looked at, right? I think no one will be challenging the decisions if they're more data oriented and study the patterns and then what is required. If it is done, I think there's no challenge. But if decisions are actually taken in and not been justified through the data, then the problems will happen. So I think it's important for people to actually start using technology, like for example, what he talked about, the simulation model and travel demand models being available. If they're used technically to justify the projects, I think it's a welcome move and everyone will support that part. Second, in terms of the traffic signaling, the points that actually came in, we are now moving away from the fixed time signal, sir. I think slowly the transition is actually happening. About 150 signals are already deployed with the new technology of adaptive. The cycle times, the offsets, the optimizations, and all that is taken through a machine learning algorithms. And whether it's a minor road or a major road, doesn't matter. It all depends on the traffic and its density. So if there is no traffic, no green. If more traffic, more green within the given cycle time, right? So that's how the system is actually going to perform. So we have done it at about 150 junctions. We'll have to wait for more junctions to actually happen on those lines. Yeah, we have actually done that part.
I think.
So. Yeah.
I think during the dinner break you can interact right now.
Yeah, we are actually doing, parallelly we have deployed a big data platform which is giving us more analytics on how before and after the congestion has changed at the junctions. So,
Sir, we'll be happy to invite students from your college to come and do the analysis if possible. We'll get a third-party view of it. Instead of patting ourselves on the back, you can come and, please, we're most welcome. Anybody here, not only you. We request everybody to come and analyze whether it is good or bad. Because our feeling is that it is good from our studies. From what we get, the sentiment is positive. Say out of 100, we are getting about 70, 80 people are happy. 20, 30 people are not happy. Sentiment is positive. But we are happy if some engineering students want to take this up. We are more than happy to share the data, more than happy to give them access. Let them come and show. So a third party will actually validate us. We are happy. We invite everybody to come and whoever is interested.
Yeah, that's a welcome suggestion. I invite all the students and teachers to kindly get in touch.
Sir, I have one question to ask. Hello, excuse me, sir. I am Maltesh from BMS College of Engineering. Sir, I am not against any roadside vendors. Pedestrian footpaths are specially designed for pedestrians walking. Most of the Bengaluru pedestrians are acquired by 80% acquired by the roadside vendors, which will directly affect the pedestrians who walk on the road, which will directly affect the vehicle movement in the road. Most of the subarterial roads, it's happening, sir. What are the action taken against that, sir?
Sir, to add to his question, there is one more question from my side. To add to his question, ನಾವು ನೋಡ್ತಾ ಇದೀವಿ ಸರ್, ಈಗ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಆಗ್ತಾ ಇದೆ ಅಂದರೆ ಅವ್ರು ಫಸ್ಟ್ ಅಕ್ವೈರ್ ಮಾಡ್ಕೊಳ್ಳೋದೇ ಫುಟ್ಪಾತಲ್ಲಿರೋವಂಥ ಜಾಗನ. ಸೊ ದಯಮಾಡಿ ನೀವು ಏನು ಆಕ್ಷನ್ ತಗೊಳ್ತಿದ್ದೀರಿ ಅದನ್ನ, ಬಿಕಾಸ್ ನಾವು ಸರ್ ಸಜೆಷನ್ ಅಲ್ಲ ಸರ್, ನಾನು ಅವ್ರನ್ನ ಕೇಳ್ತಾ ಇದ್ದೀನಿ ಅದಕ್ಕೆ ಏನು ಆಕ್ಷನ್ ತಗೊಳ್ತಿದ್ದೀರಿ. ಒಂದು ಎರಡನೇದೇನಪ್ಪ ಅಂದ್ರೆ
ನೀವು ಹೇಳ್ಬಿಡಿ, ನೀವು ಅವ್ರಿಗೆ ಅಂತ ನಾನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ
ಸರ್, ಅದಕ್ಕೆ ಅವಕಾಶನೇ ಕೊಡಬೇಡಿ.
ಕ್ವಶನ್ ಗೊತ್ತಿದೆ, ರಿಪ್ಲೈ ಗೊತ್ತಿದೆ, ನೀವು ಎರಡು ಸೇರಿ ಅವ್ರು ಕೊಟ್ಬಿಡಿ, ಅವ್ರು ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾರೆ ಅಂತ.
ಸರ್ ಇನ್ನೊಂದೇನು ಅಂದ್ರೆ, ಇವಾಗ ನಾವು 10 ನಿಮಿಷ ಡೆಲಿವರಿ, 5 ನಿಮಿಷ ಡೆಲಿವರಿ ಅಂತೇಳಿ ಒಂದಷ್ಟು ಆಪ್ಗಳು ಬಂದಿದಾವೆ.
ಹೇಳ್ತಾರೆ, ಕೇಳ್ಕೊಳ್ಳಿ, ವೆಯ್ಟ್.
ಈಗ ಸರ್ಕಾರದ್ದು ಕರ್ತವ್ಯಗಳು ಜವಾಬ್ದಾರಿಗಳು ಅಂತ ಹೇಳ್ತೀವಲ್ಲ, ಅದರೊಳಗಡೆ ಬರೀ ನಮ್ಮ ಒಂದು ಟ್ರಾಫಿಕ್ ಆಗಿರ್ಬೋದು, ರೋಡ್ ಸೇಫ್ಟಿ, ಪೆಡಸ್ಟ್ರಿಯನ್ನು ಅಷ್ಟೇ ಇರೋದಿಲ್ಲ. ಅದ್ರ ಜೊತೆಗೆ ರೈಟ್ ಟು ಲೈವ್ಲಿಹುಡ್ ಅಂತಲೂ ಒಂದು ಕಾರ್ಯಕ್ರಮ ಇದೆ. ಆ ರೈಟ್ ಟು ಲೈವ್ಲಿಹುಡ್ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಬೀದಿ ಬದಿಯ ವ್ಯಾಪಾರಿಗಳು ಅಂತ. ಬೀದಿ ಬದಿ ಅಂದ್ರೇನು ತಮಗೆಲ್ಲ ಗೊತ್ತಿರೋ ಹಾಗೆ ಫುಟ್ಪಾತ್ಸೆ. ಸೊ ನಮ್ಮ ಒಂದು ದೇಶದಲ್ಲಿ ಅಥವಾ ಏನು ನಮ್ಮ ಒಂದು ಏನು ಪದ್ಧತಿ ಥರ ಬಂದಿರೋದು ಏನು ಅಂತಂದರೆ, ವಿ ಕೆನಾಟ್ ಡ್ರೈವ್ ಎನಿಬಡಿ ಅವೇ, ದೇ ಹ್ಯಾವ್ ಟು ಗಿವ್ ದೇ ಹ್ಯಾವ್ ದಿ ರೈಟ್ ಟು ಲೈವ್ಲಿಹುಡ್ ಅಂತ ಹೇಳಿ ಅವ್ರದ್ದು ಒಂದು ಅದು ಒಂದು ಸಿಸ್ಟಮ್, ಒಂದು ವರ್ಟಿಕಲ್ ಇದೆ. ಹಾಗಾಗಿ ದೆರ್ ಈಸ್ ಎ ಚಾಲೆಂಜ್. ಬಟ್ ಅದಕ್ಕೇ ಈಗ ಒಂದು ಫಾರ್ಮುಲೇಷನ್ ಆಗ್ತಾ ಇದೆ. ಸುರಕ್ಷಾ 75 ಅಂತ ಏನು ಜಂಕ್ಷನ್ಸ್ ಇದೆ, ಆಮೇಲಿಂದ ಆರ್ಟೀರಿಯಲ್ ಸಬ್-ಆರ್ಟೀರಿಯಲ್ ರೋಡ್ಸ್ ಅಂತ ಏನಿದೆ, ಹೈ ಡೆನ್ಸಿಟಿ ಕಾರಿಡಾರ್ಸ್ ಅಂತ ನಾವೇನು ಡಿಫೈನ್ ಮಾಡಿದ್ದೀವಿ, ನಾವು ಮತ್ತು ಬ್ಯಾಂಗ್ಳೂರು ಟ್ರಾಫಿಕ್ ಪೊಲೀಸು ಜೊತೆಯಾಗಿ ವರ್ಕ್ ಮಾಡ್ತಾಯಿದ್ದೀವಿ. ಅದು ಎಫೆಕ್ಟಿವ್ನೆಸ್ ಅಂತ ಏನಿದೆ, ಅದು ಯಾವಾಗಿಂದ ನಮಗೆ ತೊಂದರೆ ಕೊಟ್ಕೊಂಡು ಬಂತು ಅದನ್ನು ಎರಾಡಿಕೇಟ್ ಮಾಡೋದಕ್ಕೂ ಅಷ್ಟೇ ಟೈಮ್ ಬೇಕಾಗುತ್ತೆ. ಸೊ ಇಟ್ ಕ್ಯಾನಾಟ್ ಹ್ಯಾಪನ್ ಆಲ್ ಆಫ್ ಎ ಸಡನ್. ಹವೆವರ್ ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ ಒನ್ ಆಫ್ ದ ಸಬ್ಜೆಕ್ಟ್ ವಿ ಆರ್ ಥಿಂಕಿಂಗ್ ಹೌ ಟು ಡೂ ಇಟ್. ಈಗ ಒಂದು ಬೀದಿ ಬದಿಯ ವ್ಯಾಪಾರಿಗಳಿಗೆ ಎಲ್ಲಿ ಜಾಗ ಕೊಡಬೇಕು, ಯಾವ ರೀತಿಯಲ್ಲಿ ಹಾಕಬೇಕು ಅಂತ ಡೆಲ್ಲಿ ಮಾಡೆಲ್ ಇದೆ, ಮುಂಬೈ ಮಾಡೆಲ್ ಇದೆ. ಆ ಮಾಡೆಲೆಲ್ಲ ಬೆಂಗಳೂರು ಸ್ಟಡಿನೂ ಮಾಡ್ತಾಯಿದ್ದೀವಿ. ಆ ಒಂದಕ್ಕೆ ಟೈಮ್ ತೊಗೊಳುತ್ತೆ. ಬಿಕಾಸ್ ಗೌರ್ಮೆಂಟ್ ಅಂದಮೇಲೆ ಒಂದೇ ದೃಷ್ಟಿಕೋನ ಇಟ್ಕೊಳ್ಳೋದಕ್ಕಾಗೋದಿಲ್ಲ ಅನ್ನೋದು ಹೇಳ್ತೀನಿ. ಥ್ಯಾಂಕ್
ಯು ಪ್ರವೀಣ್. I'm sorry. I have to conclude. You can talk definitely after the coffee break.
Sorry, sir.
Lunch break, dinner break, you can talk. I think it's my pleasant duty. No more questions. I'm sorry. It's 8:15. I don't want anyone to curse us.
One last question from the student.
During the dinner break. You can ask the question directly to the dinner break. So I take the opportunity to propose a vote of thanks on behalf of the Association of Highway Association. I thank Mr. Chakaragoda. Wait. I'll thank Mr. Chakaragoda Patel, the Chief Project Officer of KESHIP, for having kindly consented our invitation and share his thoughts during the introduction. I also thank Dr. Prahlad, who has shared his thoughts on sustainability in urban transport. I also thank Dr. Sridhar Raju, who has delivered the endowment lecture today, who came all the way from Hyderabad to deliver the talk. I also thank all the dignitaries, Mr. Anuchut, who has shared his thoughts about the traffic issues related to Bangalore. Mr. Prahlad, again, about the payment issues. Venkat Subbarao about the traffic simulation and the interaction that we would like to have with the students and teachers the years to come. I'm sure that this event today has paved way for better academia-industry collaboration. I wish all the teachers and students to make use of the invitation proposed by Mr. Anuchut and Mr. Venkat Subbarao and Mr. Prahlad. I think let us all work together. I also take the opportunity to thank Mr. Ratnakar Reddy, Lokesh and the team, as well as all the invitees, guests, alumni, students who have found time to stay from 5 o'clock till 8:15 by now. So thank you very much for your time. We look forward many more interactions in the years to come. Thank you very much. I take the opportunity to thank Mr. Anuchut with a memento. Dr. Venkat. Yeah. Mr. Venkat. Yeah, Mr. Venkat Subbarao. Thank you very much. I would like to thank Sukruti for having sung the nice prayer song. Sukruti.
So, I know a lot of students and everyone have a lot of questions on traffic enforcement, traffic operations and all. In Bangalore Traffic Police Headquarters, that's called the Control Center, PMC. Recently a museum is opened. So under his leadership, beautifully showcasing the first signal of Bangalore to what's happening now, entire traffic operations. I request all the professors to send your students one day with a prayer mail request to them. You can see and understand. Second is, there is an app called Astram. Astram is an app for Bangalore traffic operations. All these questions you can answer there, you can give feedbacks, and BTP is so open that they'll always respond to you, and then, if any good suggestions they'll take. So use that as a public-private partnership. And lastly, we want to also thank Professor Veeraraghavan. He's in a hurry to catch flight, okay? Okay. So fine then. Thank you very much. We have a dinner outside. Let's have dinner, and we can still interact and ask questions. Thank you so much for all of you coming here. Thank you.
Thank you all. Request everybody to join for the dinner. Thank you so much.